We gotta get that checked out.
That would be exciting.
Yeah.
I have a question, but I'm going to have Keith go ahead and ask
You would have been written down if I
The CAD style on the time.
I will use that in some form of back my work. Yeah, yes, I have come up with migration plan for it.
Hey, good morning, everybody. It's time for the first coffee talk of day 2 here at HPE Discover. And we're starting off today with some wonderful gentlemen from Aruba with Tom.
Tom Black, Vice President, General Manager of the Switching
I'll
Business.
hand over to you guys and you can get straight into the content.
Hi, I'm Michael Dickman, Lead Product Management for Switching.
And Christian Gilby, Product Marketing.
And I'm looking around the table. We actually do have a coffee chat this morning, so this is good.
First thing in the morning, we all need coffee.
Absolutely. All right, well, hey, thanks everybody for joining. I hope you brought your questions, your hard balls, your soft balls. If it's a fastball, Michael's got to swing at it. All right, so I'm going to guess by now everyone saw the launch of the 8400 this week. So I think we'll focus on that first. So for those of you that may have seen the spotlight, we'll just hit a few factoids on the product. This was a huge piece of work for us as an organization. You know, when we looked at the whole portfolio, we felt really comfortable with the access switching product line, the 5400 chassis going up to about 2 terabit, but we were kind of missing that switch up at the 10 plus terabit range that you could put in the core of the network. So well over a couple years ago, we started the design cycle on this product. As I mentioned in the spotlight, this has had hundreds and hundreds of engineers, well over 600 engineers focused on this. This has been a labor of love. Takes a lot of perseverance and a lot of focus to get to where we are here this week. So really proud of the team. I think the things that are really relevant to understand about the 8400 are that while it is an incredible 19 terabit packed into 8RU sort of package, and we can talk about the system design if you guys have technical questions later. But kind of the real story is the operating system. So we like to say AOS-CX is the first network operating system built for operators. So the way we designed this is we had a 20-year source code base and solid layer 2, layer 3 protocols, but we really wanted to create a modern platform to take us into kind of the mobile and IoT era. So what we did is we lifted up those protocols and really built from a ground up a massive cloud application that is known as our network operating system. The protocols, if you will, are applications that run think of them as microservices in that cloud application, and that's really packaged up and delivered to you in the form of a switch. The really interesting thing about that we didn't have time to talk about yesterday is AOS-CX is not just APIs for API's sake or everybody's got an API story. We actually, the fundamental architecture of the product is everything in the switch is in a data model and a database schema and held in that in-memory state database. So as part of the compile time, we actually auto-generate REST APIs for every variable object state you can imagine in the data model. So all APIs are actually done not by humans as an afterthought, but actually done by as part of the build system at compile time. So it really is API first, and all the various different applications that run in AOS-CX really rely on that data model and that pub sub cloud sort of approach to building distributed systems to work together. So the whole thing again, ground up cloud application. I've briefed probably 40, 50 customers prior to Discover, and it's been received, 8400 platform kind of from a speed specs, received really well. AOS-CX, whether it's CTOs, VPs of networks, technical people, people really get it. So I've been cross-examined by some really smart people that I appreciate, really smart customers worldwide, and the architecture and the approach really resonates. But as we talked about yesterday, the one innovation, if there's kind of one thing you remember about what we're doing here this week, the one innovation that we really decided to make the tip of the spear and how we were going to go tackle the core of the network was something we've branded Network Analytics Engine, or NAE. What NAE is it is another application that runs in AOS CX that sits on top of that data model, uses those APIs to basically monitor, analyze, kind of reprogram if necessary any of the attributes in the operating system on the fly. So you can really think of it as you've got real-time analytics happening in the network as things happen. So you take as we were talking about yesterday, you take a typical sort of use case that would happen in a campus network. You've got a transient outage in a building, potentially a spanning tree loop, interfering with UCC traffic. Normally what happens is network operations says, okay, they try to go pull logs out of systems, try to figure out what might have happened at 9:04 a.m. when everyone got in the office and got going. This is different. This is real-time monitoring and analytics running on the box all the time, recording what's happening. And so at 9:04 a.m. when you had that outage, data was collected, potential remedial actions were taken as part of the monitoring policies to fix the issue. And so network operations isn't doing retroactive kind of human-machine sort of troubleshooting. The software is doing constantly monitoring and doing the troubleshooting for you. So that's really the focus of Network Analytics Engine. One of the things that, again, we didn't have time to talk about yesterday is the NAE is actually user extensible. So there's on the hard drive, on the management, on the route processors, there's a safe directory where customers can upload their own Python scripts, their own policies. Those scripts actually, if you use the format we suggest, they'll actually auto-generate web pages in the GUI, so you don't have to design new GUI pages. You get them when you put the script on the box. And with those scripts, you're able to customize what you want to see. So you might want to, look for BGP peers gone down and then do a show tech, or then walk the rib or the fib, dump some data. Whatever you think is relevant to your use case, what you want to monitor for, and what you want to do when those triggers happen, you can customize it with your own scripts. And what we're doing is we're actually building a community on our Airheads portal and recipes in our what's called our ASE, or is a piece of the Ruba website, but kind of a place where network operators can share their scripts together. So you have people kind of building on each other's knowledge, leveraging scripts. Obviously, every release will continue to add more capabilities, more events that we find interesting for customers. Our technical support can obviously add scripts as well, but really that user community should pick up over time, and you'll see some common knowledge about, oh, hey, you had that kind of problem, here's a script I used to monitor for that event or take action. So, Michael? Yeah, go ahead. Got a question? Good.
All right. Just out of curiosity, I know Salesforce has a similar thing, right? With everything that they have. Thwack has something that they do. Is this something that you could see opening up to a marketplace, just out of curiosity, so people can monetize some of the scripts that they're... I mean, listen, I'm an airhead, and I totally appreciate the community. However, if I take the time to write a script that does something pretty spectacular, any thoughts there?
We actually haven't looked at a business model like that. Certainly, someone could create scripts and sell it to their buddies on eBay. I just bidder. Yeah, you get the USB stick and the postal little posted U.S. Postal Service
5 1/4 floppy disk.
Yeah. Oh, hey, no, that's a low blow. But no, we actually hadn't thought about that. But who knows what could come about?
Yeah, just to add a little bit there, we can show you a demo at the booth later if anyone hasn't seen. But the scripts can actually be remarkably short and very, very easy. And so one of the premises around... Hello?
Yeah.
Sorry. And one of the premises of the way we did it is basically to make this as accessible as possible to network operators who aren't today programmers. And so that is actually part of the way we thought of it, is just to make it as easy as possible to enter this world of, you can call it API-based programmability, or you can call it, automating the kind of manual troubleshooting that's been done in the past with as low of a bar as possible. And so far, that's our approach.
And I mean, I talked to him yesterday about integrating it with IFTTT. Something ridiculous. Turn on your hue lights when you have a network problem.
Okay.
but it's
So one of the guys on the floor did that. So he said, hey, come here, watch. I got a script on a show at Discover. I said, what? He said, I take the interface down, it turns the lights on at my house. And he showed me his Nest camera at his house, and it did that. But honestly, most of these scripts, to Michael's point, are really short, right? So that UC&C demo that we're doing out there, that's 10 lines. Because what we did, part of NAE is we built libraries for really common functions. Think of almost like, if you're a spreadsheet user, you've got some average, blah, blah, blah. So we built, there's a whole arsenal of things that you get to call in your script. So it's not like you have to invent everything on your own from ground up, right?
No, and on the opposite side, and I've asked this question, I think, to every person that I've talked to about the 8400 is, as far as licensing goes for this, I just want to make it clear since we're recording things now. But that's because no one's heard me ask the question. But this is included. This isn't some weird license feature that you add onto it. This is you get the 8400. This functionality is built into it. There's nothing extra you have to add to it.
That's correct.
That's awesome. Good job.
Yeah, go.
Okay, thank you. So now that we have a lot of host PC devices like tablets and cell phones, is the software ready for making changes on the fly, or do you have any specific strategy for these post PC devices?
Yeah, I'll take a stab at that. I think, right, so being in the core of the network, this is basically where all the traffic is coming through. And one of the things, I think maybe Kirti referred to this, is we try to, as Aruba, always start out with this like mobile cloud IoT era. And maybe I'll make it like specific with some examples, and hopefully that'll address the question. One of the things we've seen with mobility is an explosion in, say, like mobile UC, mobile Wi-Fi, mobile collaboration. And so that management of that voice network we think is more complicated. And so that's one of the examples where we think you need to have more granular troubleshooting end to end. I think IoT is one where, at least from my customer conversations, has been even more painful than talking about the mobile devices in the core. And the reason for that is a lot of our customers are having a VLAN explosion. So what's happening is someone will come and say, okay, I just bought this new sprinkler system and I need to connect it. And someone else comes in and says, I just want to connect my HVAC system. We even had a request for a connected fire extinguisher. I don't know if I told you about this one. And as the networking team doesn't know what to do, by default, they're creating new VLANs. And this is creating complexity. It's creating segmentation questions, management questions, consistency questions. And for you to have central visibility to that is absolutely an unsolved problem. And so the way we've built this can do, exactly what VLANs are running, instant refresh. You can do correlation with config changes. You can see across the if this then that framework. And so, at least from my perspective, the mobile side will be a lot more on the complexity and volume of traffic that's going through, and the IoT is around the visibility and network complexity that's starting to arise even on the wired and wireless side. And we've definitely considered that. And then, of course, the speeds and feeds is affected as well, but maybe that's sort of a secondary point. But I'd say the main point will be that visibility, troubleshooting logic from a more mission-critical, harder to manage traffic on the mobile side, and this very big challenge of visibility on the IoT side.
Yeah, I'll jump on and I'll give you a slightly different answer. Okay, so if you go back 15 years to before the mobile tablet era, you go back to PC era, client server, right? Applications were built. Maybe people around the table did it with environments like Visual Studio for Microsoft, right? So what you did is you took everything you needed for an application, you compiled the bits, and you delivered something that had to get installed on a system, and that's what you got was just that application. And someday, if someone built a new version of the application, you'd reinstall it, and away you go. So you had these huge monolithic apps. Okay, that's what most of the network operating systems in the market are like today. They're just a big monolithic app that let you, kind of stimulate the CLI on top, and the bits happen on the bottom, right? AOSCX is very different. It is really, if you will, a disciple of the modern cloud era, of the tablet era, in that it isn't a monolithic application. It's a framework from a kind of a computer science distributed systems perspective that small applications are added to, and both in the first release and over time. That collection of applications is what we call AOSCX, but it's not. Its design center was it's intended to be a piece of software that other software can integrate with for their own purpose. It's not a human machine first design center. It's a machine first design center. So it's meant to be, I think I used the term on stage, network as a microservice, right? It's meant to offer up a bunch of capability, just like if you had, a billing microservice, or you had, some other component you were using to build your web application or your cloud application. AOS-CX was really designed to be just a component in a larger software stack. So, of course, we'll integrate it with our own software platforms, right? You've heard talk this week about ClearPass and Niara and our cloud platform, those kinds of things. But from a customer operations, I was with a large systems integrator yesterday that has many divisions, things in healthcare and other areas, and they have a full stack that they bring out as solutions, right? So AOS-CX becomes this very natural component in a stack of many other things. It could be other networking components. It could be medical gear, operational applications, et cetera, et cetera. So its design center is that cloud and tablet era, again, really meant to be integrated with other software for software's sake, if you will.
Yeah. Another question. Oh, that's fine. So now that we have the analytics and we have the API, do you have any use case when you can use machine learning and artificial intelligence for making changes on the network without any human interaction?
Yeah. So I'll give you one that you'll see happen from us. So I think hopefully you saw us talk about Niara yesterday, which is kind of a day two. It's not a perimeter security. It's machine learning AI for monitoring when things could have gone wrong, within your network. The average security breach runs about 140 days plus in an enterprise before it's detected. So Niara is a platform that gives you the ability to detect those breaches early on and then figure out what you want to do with it. For security applications, for machine learning to work, they need data, they need sensors, okay? So when you think about streaming all the data that's going through the network up to a machine learning application, that's a daunting amount of telemetry. That's a lot to wade through. So typically what you'll see is these kinds of machine learning apps want to see a set of things. But what's powerful with Network Analytics Engine is, again, right, it's meant to be integrated with other pieces of software. As a platform like Niara starts to detect an anomaly, it can immediately go to the core switch and start to window in on the telemetry it wants to see next. So it may have been gathering DNS queries across hosts before, for example. I'm just making this up, right? But and all of a sudden it detects a host is TCP sending, all the servers in the data center. That's a strange thing. So now you want to zoom in on that host. You really want to see all the traffic on that host, not just DNS queries. You want to understand exactly what that host is doing. So that ability for software, the machine learning software, to decide where it wants to go deep and automatically get that from the 8400 and then figure out what to do. It could, in that case, it could actually signal to ClearPass to re-auth that client, and the auth fails and we boot that client off the network. That's just an example of a very simple closed loop machine learning to deeper visibility from the network to remedial action to thwart potential security breach.
And then I'll just add a little bit on the operations side. I think also we're keen to learn from our customers, because so far what we've heard, the feedback is a lot of interest in automated troubleshooting and recommended remediation, but not to automate remediation. But actually the system can automatically revert configuration or make adjustments. And so this is actually something that we're really looking forward to seeing, what the market wants in terms of true automated remediation versus recommend it and then let the human take that next step. But from a technology perspective, both are available.
Yeah, show and do are just two different APIs.
Yeah.
Thank you.
So a little disclaimer here, I'm a virtualization guy, so when I hear we've got a new core switch out there, I'm thinking speeds and feeds talking directly to like a Synergy chassis, and going out to the edge with wireless pieces, that's literally somebody else's problem, okay? So the first question that
Michael, we're somebody else's problem.
Okay. Just disclaimer, framing that up. So, but the idea of a nice new API-driven core switch has a lot of appeal. Being able to displace some of the competitors, there's some appeal to that. But we're also seeing a shift with all of the, you call it NSX or ACI or any of those that are the overlay networks that give us more and more of the programmability, not just from a VLAN instantiation, but the whole, I don't even have to plug things in a second time or because it's already done. I'm doing close networks or leaf spine, however you want to call them. Where does this fit in? And if we've got the wireless controllers on one side of the Aruba product sheet and I've got a core switch on the other side, what are we doing for both the distribution and top of rack stuff? Is that on your roadmap, or is that still HP Networking's bailiwick?
So the Aruba portfolio is campus core, distribution, access, right, from a switching perspective. In data center, we partner with Arista. So right now, we don't have ambitions to take the Aruba portfolio inside the data center. We trust our partner to fulfill that particular place in the portfolio.
I have a question. So it's kind of along the same lines he was talking about. With the new OS, when you're talking core switching, you're talking reliability, stability. What kind of mechanisms have you put in place for building the new OS, for one? Like, what has that been through? Was that based mostly on Aruba OS or on some HP OS brought into it? What do you do to stabilize that? And then what kind of testing, what kind of mechanisms have you put when you're doing all of this integration with a lot of different third-party? What are you doing to protect that core switching? Because when you're core switching, that's really the most important thing it's supposed to be doing. Can you talk about that a little?
Yeah, sure. So we did architecturally, it's not just a cloud application. From a development methodology, it's a cloud application. Okay, so when a developer checks in a piece of feature code or a bug fix, they actually check in the test cases for that feature code or the bug fix at the same time. So it's continuous integration and test. It's not CI/CD like a website, right? You can't just update, your public facing. If you have a website, you can update the code at will, and as people go to it, they get the new version, right? This is different. The bits have to ship, but short of shipping the bits, we have a continuous integration and test model in for AOS CX. I was fortunate in that the organization had made a significant investment in automation in general. So I have a massive global data center that we do automated tests, not just for the 8400, but for the whole portfolio, including even interop with other people's gear. So to complete lights out layer 1 through 7 data center with hosts and clients and test sets, products of every sort. You can build very complex topology. So one of the things we've got a good reputation for is software quality and hardware quality in the switching products, and I'd like to really credit kind of the development methodology and the automated tests that has been they've been really key to making that happen. So the 8400, the kinds of test cases we have, our ability to test it with kind of black box software on the system evolved and is different than in the past for us. But that kind of automated end-to-end test, that's in our DNA, it's in our genes. And so AOSCX was just the next iteration of that sort of approach.
On the OS itself, I just want to make sure we touch to that question. So we've taken a lot of the existing kind of investment around protocols, but the infrastructure is really what's newer. And I was hoping you could talk about the state database and some advantages of high availability through that model.
Yeah, so I'll describe it briefly, and then I'll give you something that happened in our production beta, just as a use case. So we talked about the data model, the database, the schema having all state. So if you're say a spanning tree protocol, everything about the current state of every port or every port in every VLAN, right, for something like PVST, is held in the database. So if you crash, if you have a bug, when you restart and that daemon comes back up and runs, it reattaches to the database and it sucks its last known operational state out of the database and just keeps going. So actually in our production beta, we went into a large school district, and turns out there was between some of the Windows clients and a fairly early version of the code, there was a bug in the DHCP server. And the DHCP server was actually crashing a few times a day, and other than the syslog, no one knew it happened, because it would crash, come right back around, reattach the database, get its last known good state, and away you go. Now, in a core switch, to your example, high availability is table stakes, right? Some people do it better than others. But this is where the software architecture has an intrinsic advantage. So in old network operating systems, when you did a switch over from the primary route processor to the secondary, typically what happened is all the layer 2 protocols would sync their state. So spanning tree would talk to spanning tree, and layer 3 to layer 3, and port manager to port manager. All these applications are trying to sync everything across from primary to standby, and that kind of decoupled nature of trying to make that switch over hitless takes a long time to stabilize in the field. So most NOSes got to real HA either after many years from first attempt, right? This is where AOS-CX has a distinct architectural advantage. So rather than have the applications on the primary and the standby sync, what do? We use 20-year-old technology or computer science to do database replication. So what happens is, on the primary, the active database is actually replicating its state to the standby, just using database replication. And we hold all the control plane applications on the standby, we hold them at boot time. Okay, so when we switch over from primary to standby, all we have to do is let those guys go. And as soon as they fire up, they attach to the database, they extract a known state, and they're up and running. It's now the new primary. So actually, there's no difference between a process restart because of a bug or a switchover. Architecturally, the applications don't know. All they know is I come up, I attach the database, I get my last known good operational state, and I'm off and running. So HA is actually intrinsic in the architecture of AOS-CX.
And just for completeness on the hardware side, because there are some table stakes expectations there, we do have redundancy in all the hardware elements. So we have redundant fabric, redundant power, redundant management modules, redundant fans. Yep. And so on the hardware side as well, it's, I don't know how many nines, you'll have to talk to that, but it's if you look at a core internet router from any of the prominent companies, you look at our partners, some of our partners' core data center switches, they'll have, at this point in time, they tend to have a similar architecture from a carrier class perspective, and AOS, the 8400, I would say is as modern gets in a core system architecture.
Do you see pushing this OS to the other switching models, or is it just going to stay with the 8400?
We'll look at that over time. Right now, the design center was let's get into the core of the network. Let's do it really, really well. Stay focused, deliver. I think I don't know if the demo's on the floor, but we're doing things to integrate NAE with the REST interfaces on the rest of the switching portfolio. So you can start to do analytics and take action across both access switching and core switching. So I think one of the demos I saw last Thursday, maybe you were even, I saw it from Christian, was detect the voice over IP queues, had backed up in the core. The 8400 would call the REST API and the access switches, kick off an IPSLA probe, get the MOS scores for the Skype calls, bring that back to the core switch, say that report saved on disk, it's now hyperlinked into the report and NAE for that particular monitoring policy. So we're doing integration more from a workflow perspective. We'll look at where the OS goes at farther down the road.
And I wanted to follow up on a question on that. And I saw that demonstration. It's fantastic. But is there, and to clarify what we're talking about, and the question I asked the guys out on the floor was, if you take the 8400 and obviously core switch, and you take the access switches, they're out at the edge. The data that's being fed back into the core switch, the core switch acts as that master aggregator to the big troubleshooter, the big brain on Brad. The access layer switches that are coming in, is that a real-time feed that goes back in, or is that just, like a query to go out to the access switch, grab a piece of data, bring it in? Or is there something that's going to be set up or that is already set up so that you can get real-time data from those access switches to feed back into the core switch?
I'll start and let Michael finish. Okay. It depends on how you define the policy, what you want to do. It's kind of your option, but maybe you.
Yeah, so that's the main answer, is it depends. I think one thing we're not doing is we're not going to make the core switch like a new network management system for everything. So just, in terms of what to expect, where we'll be focusing on is those operations and troubleshooting workflows. And in that regard, we expect in some cases you'll have API calls that are real-time streaming data from the edge. In other cases, only if there's an event, like the if this then that. Yes. Only if we have an event and we need that data will we go out and get that. And at that time, it'll be real-time and streaming.
Okay, and that's to use your example of working with Niara, so that Niara can trigger an event, say, hey, there's an anomaly, there's something going on. Open up a stream to come in and bring all that live data, and that's more because I see what you're saying. Making an NMS box is not. False.
We're not redoing NMS. Yeah. we actually have a really good NMS platform called Airwave, right? So,
yeah, right.
We're not redoing that. You had a question, sir?
So, from a enterprise architecture perspective, one of the difficult things when a cool new product comes on the scene is saying, this isn't, from the stage was announced, you can go catless. There won't be, you can get rid of cat OS or catalyst switches out of your core. One of the primary drivers for keeping that stuff in the core is that large enterprises like single vendors to get their entire network stack from. It's just part of the architecture and the engineering and operations. What's the core value, to borrow a term, what's the core value of displacing my all Cisco network with a Aruba core and a Cisco top of rack and other access layers?
Yeah, so let me reflect a little bit of some of our customer conversations, and then I'll come back to the broader kind of business question. What we've seen from customers is in the past, I think they said, I'm going to make a Wi-Fi decision, then I'm going to make a campus switching decision, then I'm going to make a data center switching decision. What we're seeing more is a customer saying, I want to decide for this building how I want that architecture to run to deliver the best experience for my users. And in practice, what we've seen is rather than, one vendor at this layer and another vendor at this layer, we're starting to see one vendor in this building and another vendor in that building. And that is a much more common model that we're seeing for that operational consistency and user experience. And I think it's because of some of those trends that the question over here referred to around mobility and IoT, where to have that consistent operational model within the same kind of physical location is now making more sense than a broad-based layer-by-layer siloed decision. And especially speaking from Aruba, we view wired and wireless as two different ways things could access. Like you could be over copper, you could be over fiber, you could be over a radio, etc. But these are all different users and devices, and so we're actually spending a lot of effort and time to unify that experience. So like at the access layer, and then how that integrates with the core. So that's one point. I think the other point would be a lot of these situations, the core switch is very, very old. And in fact, any new switch from any vendor would be running a different OS than it runs today. And so that's just kind of pragmatically, there's not, the 15-year-old OS that might be there today is not necessarily the OS that you would get, from a new device from any vendor. So that's a consideration. And then the last point around the switch is we really have spent a lot of time thinking about how it fits into the architecture. So like you heard the Nara examples, Airwave will be monitoring the switch, how we're tying those REST APIs kind of natively into the access layer. All of those are building out this entire mobile-first architecture that extends from the user up rather than from the wired core down. And so really focused on that user and IoT experience. And we've spent a lot of time on that architecture. So what we'll expect is customers will be making a decision if what's important to them is mobility and IoT, those kind of things, then we would expect them to make building level decisions. And if what's important to them is, here's my traditional organization of teams around layer by layer, then it may be different. But we're certainly seeing a shift in our customer base towards what are those new disruptive trends and having a single vendor per building.
Yeah, I'll tack onto that a little bit. So first off, I think the 6500 is probably, I think, it's the most successful networking product ever in history, right? So there's a lot of them out there. Keep in mind, the vast majority are capped out at about 80 gigs a slot if you put DFCs on them, right? So they are long in the tooth. Again, phenomenal platform, but as Kirti said, it's time it retires. In fact, Cisco itself tried a couple times to move 6K to 7K, and they've kind of gone back and forth with, I think, with what really is the lead pin or the lead product at that place in network. But you can almost look at your question a different way, sir, which is, I've got a bunch of customers that said, look, I've got you everywhere. I just need to get that one last thing out of my network because I want you there too. What can you do for me? That's why we built the 8400.
So it sounds like you've got, with the new switch, some great on-box visibility. Is there also a way to get a full picture of network state, or is this more about having that deep analytics box by box?
So again, we will rely on our platforms like Airwave, Niara, et cetera, to give you that full network view. So again, AOSCX really, it's a box level thing. Where to the chat we were having earlier, where the line blurs a little bit is it can actually call into other applications or call into other switches to do things, right? So again, it's how you choose to deploy your NAE agents. But in general, full network visibility state, that's the responsibility NMS, not a switch.
Okay, I'm going to play devil's advocate here. Keith asked you guys a question and said, what makes this a core value? And you guys basically said, because it's new. That's cool. I mean, that's a good reason to upgrade, right? But I think I want to elaborate on that a little bit more. As far as cross compatibility and functionality wise, I think the thing, Keith, that I got out of that was that if you go back to what they were saying before, it's a machine-to-machine box. It's not necessarily a user machine box. So would it be a fair statement to say that one of the reasons that it makes a good play is because it can work with other equipment that's in your data center? So, I mean, and is that a fair statement? I mean, the Niara software, you can, like we're talking about opening up those data streams from access level devices. Doesn't matter if it's a Cisco device or a Juniper device or a Brocade device or whatever. It's APIs or APIs.
Yeah, so certainly we always do the open standards. We'll work with multi-vendor, and then the API calls, to the extent that they're well-structured API calls, will work in and out. And then also just where you started, I wouldn't say our core value prop is that it's new.
No, I'm just digging at you for fun.
Which I totally
We're trying to get the
appreciate.
viewer count up here, man.
Yeah, no, I got it. But it's really what we were talking about earlier, like the advantages around that flexibility, modularity, visibility, automation, all embedded in the network.
Okay.
And then it's kind of like, and oh, by the way, it's 1.2 terabits per line card.
So yeah, I mean, a little bit, So, and I had another question, and I asked this yesterday, and it has to do with the, you talk about the on-system database, which I think is, and we haven't talked too much about that, but I found a lot of value in that understanding. I mean, you did touch on it now, how each component is basically a service or a microservice that taps into that database, and so if that microservice fails, it crashes, it comes back up, but the data remains the same. Just to clarify, that's all stored on board. All that is stored on those management modules. Yeah. And I believe it does have SSD. It's got an SSD. Can you talk about that a little bit?
Yeah, so it's a quad-core Xeon, 32 gigs of RAM, and I think 128 gig SSD or something along those lines.
And it's you can put dual cards in there, right?
Yeah.
Okay.
So I wanted to come back to Keith here. So this is you have to kind of rotate 90 degrees, right? So core switching, right, for decades has been, while it is the transit point of the network and it's where all the traffic is going through and potentially is the richest pin or the richest place in network to harvest information and data, right? It's also the largest failure domain. So the general operational tendency for core switching is, God, don't touch it, right? Get it stable, find a release that works, and then everybody stay away, don't touch it. Right, so you get a change window. It's a 2-hour change window. 1 a.m. on Sunday, and everyone hope and pray that it's okay Monday morning. Right, so the conservatism around interacting with that place in network is just rampant in network operations across the globe. Right, AOSCX is intended again to tilt things 90 degrees, which says it's okay. You can interact with it, software to software. You're not it's not going to crash. You're not going to take your network down. Go ahead and take advantage of not just the stability, the performance of the system, but take advantage of the value, the data that's going through that box, because it's safe to interact with. That make sense? So
I guess there's the technical conversation, and then there's kind of the reality when you hit the business. Well, I like probably the best analogy is when I have to create a business case for replacing a core network switch. I can go to this. Normally, this is like in a lot of organizations. This gets to the CIO, CEO level conversation, and they have to make a decision: do I buy a forklift or a new set of forklifts, or do I buy a new core switch? The core switch that's there today gets me my email that I get today. How does a new 8400 translate into new business opportunity or new business value? Is a lot of the conversation I'm helping network engineers make. So from Aruba's perspective, the software capability of 8400, how are you guys helping these network engineers, network managers make it's a reason why Cat 6500s have been in the core of the network for 15 years. The perceived value of the core isn't there. So how do you help change that perception of value of core network switching?
So I'll start and I'll let Michael finish. So I actually think customers really do value their core. They're just afraid. They've just been afraid to touch it.
So it's a different value. It's the network engine. Yeah. I'm talking executive. This is the network manager. Yeah, he values it. The CEO or CIO that has to approve the risk in the and the capex to move to a new core doesn't necessarily value it. That's a much automation. I understand automation, virtualization. I understand virtualization. Cloud move to cloud. I understand that. From a CFO, CEO, business users perspective, what's the new value? Because that's who has to approve this purchase in the risk of the migration. So if I'm selling that, what's the value I'm taking into that? What's the tag or value line that I'm taking into that group to convince them that, yes, we're going to spend X tens of thousands of dollars, take on this amount of risk to change something in their mind that isn't broke?
You want to go first?
Sure. So, talking to CEO level, it is a good question. It is a good question. Talking to a C-level audience about this, I would say agility and security. Agility is, we're hearing from our customers because, the core hasn't maybe been touched and had enough attention and so on. It is actually holding back. So maybe I'll give some examples. I talked to the global professional services firm. The core switch was the reason that they were unsuccessful in deploying a kind of new video collaboration conferencing system worldwide. They had a lot of struggles with that in terms of just the creation of the service and going through. And so there's these examples we're hearing where services deployment is slow, and one of the reasons is actually the existing infrastructure. The second part of agility would be that operations troubleshooting. I mean, it's almost like a cliche now. 70% of the cost and time is spent keeping the lights on, and we really think this is going to help address that in terms of network operations, automation, troubleshooting, visibility. Another example, spoke with a university in the West, and they're down to 5 people in the networking team, and they actually have research groups, which is relevant to the president of the university. They got research groups who are complaining about the network team because they can't get what they need to do their research. And the reason is that everything has to be manually set up for these research groups every time they come in. They look at something like the 8400, they actually took it further than we thought, which is to make it even self-service for research groups. So they have that much trust in this. So that like an intelligent, sophisticated research group of a university can now set up their little network sandbox in terms of all the pieces around that, including the core. So that agility piece, I think, is one. And then the second is that security piece. To take it to that next level in terms of really sensor more than enforcer, but really that intelligent sensor, I think to the questions you were asking earlier, that when you need information, you can get it instantly at the granularity you need, sent to the service you want as a co-equal part of that software environment. I think that's going to be key because this really is that center point in the network. And rather than trying to manage all traffic from all points or stream 100% of core traffic, it's really that intelligent security interaction is going to be very helpful with some of the other modern tools. So those are the two pieces I would say at a C level.
So let me let me tag on that real quick. So the majority of my briefings pre-launch were with CTOs or CIOs. Okay, and I'll tell you how the discussion went. Switch, And as soon as you get to 10AE network analytics engine, the conversation completely changes. And I'll tell you why it matters to CIO. Because the CIO has got lines of business screaming at him to get this project done, that project done. That there could be, whether it's corporate UC&C, whether it's improving throughput from an engineering data center to workstations. There's a laundry list of stuff that's happening at that level of the organization, and beyond just performance of the network, the thing where the eyes really open up and where we get phase alignment with that level of an organization again is around NAE, because they can see that the pressure they're under to get some of these projects done and users happy, that cycle is de-risked and compressed with NAE. So they've got the opportunity. They know if something goes wrong now, they'll be able to jump in and more quickly figure out what it is and get it fixed. Because to Michael's point, they'll often try to deploy a project, a major new project, with touching as little of the interior of the network as possible, right? You're just trying to add applications or devices around the edge. But that is now an impediment to getting some of these projects through. So NAE really is where the discussion shifts.
So just a couple of thoughts there. I'm not questioning Aruba's value in this, but just in terms of what I've heard, it could have been Cisco saying the same thing. It could have been another vendor saying the same thing. So just some feedback. I think you have to be a little more clear on your differentiated value as you start to articulate it, so that your competition isn't able just to say the same thing, and then I'm left as an executive going, okay, so who do I believe more? Because that's a roll of the dice, and that kind of gets to Keith's piece. But I would also say we're not talking tens of thousands of dollars. I mean, in most of the infrastructures that I've managed or clients that I've worked with, we're talking hundreds to millions. So it's an incredibly expensive component, and it's not just the capital exposure, it's also the staff and the training and everything else that goes with it, right? All the ancillary pieces. That almost becomes more complicated than just simply replacing one product for another. So just some feedback to you.
Thanks. Yeah, I think we don't want to do negative competitive campaigning, right? So
I highly suggest that
what
you
we're
do
going
not
to do-
follow in the
Yes.
footsteps of some of your other folks that have gone down that path.
Not in our DNA. So we are very comfortable, though, to your point, just let the software do the actual talking.
And then just the other thing I'd add is we really have focused a lot on the network operators experience. And so in those level conversations, we're getting good feedback. But you're right. I think when you boil it up to just two buzzwords at a C level, it's hard to, pick a brand new buzzword no one's ever heard. So that's fair feedback.
Back a little more on the technical. Do you have any plans for something like VSS? I think HP calls it IRF, anything like that. And then what about span limitations, things like that? I know there's kind of basic, but it being a new switch, what kind of limitations do you have there?
Sure, so I'll take the first and maybe you take the second. So on the kind of virtual, I think VSS, you're referring to virtualizing the chassis so that you can have logically managing it as one domain and getting that redundancy fault tolerance benefit. So we call that technology VSF, Virtualized Switch Fabric. And yes, this will be supported in that chassis. And so we'll expect in general, I think, most customers will probably deploy two of these side by side, with VSF in most deployments over time, would be our expectation of a typical deployment model.
Span sessions, we'll have to get back to. I forget the exact number, but the question is very, very interesting because it's about that was the troubleshooting tool that came with a bunch of hardware and software limits and what is in the market today. Put span session aside. If your policy says look for this kind of data and copy that packet somewhere else, that isn't constrained by the concept of a span session, so to speak, right? Because a policy-based forwarding, a span in some ways is just a policy-based forwarding decision, right? It's a mirror of a packet, but those kinds of things are just intrinsically available in the software. The exact span session count, though, we'll have to follow up with you.
Hi. One of the things that really got my attention is around the APIs, the idea that every state is actually reflected in existing APIs that exist. I think this creates an immense developer opportunity as well as the project portfolio that you mentioned before. It affects sourcing decisions. It affects the ability to really be able to handle real-time alerts in all of your other monitoring solutions. I didn't feel like that part was built out too well. I'm curious, most of all, in understanding with all this data, all the analytics you have, how much out-of-the-box support do you plan to provide on integration with other troubleshooting and monitoring solutions across the board? Because this could be useful for everything from the obvious, such as network monitoring, where you already have some solutions as well, all the way to, say, IT expense management, sourcing, project and portfolio management, where core switching could be seen as one of the resources associated with anything from cloud upgrades to whatever application projects are in place.
So I think I'm going to let Michael take most of that answer. But just to go back to the first part of your question, you may have seen on the floor we use Swagger to auto document the APIs, right? And so we have scripts already that, and with that technology, you can cross compile the APIs into Python, Ruby, and there's a whole list. I think you see that matrix of about 20 different languages or platforms. And again, as we showed on the floor, one of the things we do already is we auto-generate Google spreadsheet functions for all the APIs, right? So it's just an output of, it's a natural consequence of being a cloud application. You've got that kind of latitude. Deeper integrations with other systems, I think it'll happen over time. But what are you seeing in customer conversations?
Yeah, first of all, I think it's a great question and a very rich area that'll evolve over time. we've already done some examples ourselves of integrations, things, the tools Tom mentioned, things like GitHub or GNS3 or Jenkins, spreadsheets. So these tools are remarkably easy, and I think what we'll do over time is expand the way that we talk about how easy that is, and then also where there is value in a bilateral integration, we could pursue that. I think from my perspective, I want us to be customer-led in terms of which of those integrations add the most value. And so far, I would say the number one integration point that I've heard is actually a homegrown orchestration system that directly leverages the APIs. And then the secondary would be some of these data center type tools around operations automation. And then we'll go from there. I think it's a great point, though.
So I have to get this dig in. This is nothing to do with this, but Amy on Twitter, they said, can you find a way to bring faxing into the conversation?
Well, they were talking about analytics for VoIP. You got to, know if your faxing is working, right? Support T38.
That's an inside joke.
Okay.
You do not have to answer that.
Sorry.
Do not have to answer that. Thank you.
Bill's got what?
So I think we're done. Everybody's asked their questions, and we'll catch up with the guys on the Aruba stand here. So thank you very much. And
Hey, thanks everybody for your time today.
And we'll be live on air again in about 15 minutes. All right, we're on time for away for our next. This one is some nice IoT with GE Digital. We have Trip, Andrew, and Geetus, and I'll hand it over to you guys.
So good morning, everyone. I'm Geetus Barsdukas. I think the way we're thinking about this is I can just provide a little bit of an overview of what Predix is and what GE Digital is doing in this space, and then you guys can follow on with the relationship and some more details. So GE Digital is a new division within GE, relatively new. I represent Predix, which is the platform for building applications, so industrially oriented applications that are targeting manufacturing use cases as well as use cases in other industrials such as power, oil and gas, aviation. We also have customers working in building services. We're talking to customers in the automotive space. So we're looking at this as being broader than just services provided to the customers and the businesses within GE. We've been in market since February of last year. So we are a cloud platform that also has capabilities on the edge. So we can take and gather information from customers' production facilities, manufacturing facilities, operational environments, oil platform in the North Sea, a power plant, a wind turbine, or wind farm, if you will, a fleet of wind turbines sitting out in the ocean offshore. So what we do is we actually pull data in from those through sensors, through gateways, through servers, bring the data back in, allow people to do predictive analytics around that information for maintenance purposes, operational optimization, things of that nature. A couple of things where we differentiate ourselves from the standard infrastructure as a service platforms. We're all about industrial assets. So if you think about the difference that we have is we've got years, decades of experience in the industrial space. So a lot of the knowledge around how assets work together, how industrial assets integrate and operate with one another is something that sort of differentiates us. We have a store of analytics that are specific to the industrial space that can be applied. Traditionally, they've been applied very much in specific verticals, but we're seeing the opportunity to apply those analytics across different verticals. And one of the concepts we talk about extensively is this concept of a digital twin. So it's the ability to create a digital representation of a physical asset. Taking together data coming off that asset, applying analytics, all built within an asset model that brings it all together. It's not just how the asset has been built or designed, but it's how it's been operated over the years. We've got a lot of experience in that internally, and now we're looking to build a platform where third parties can bring their knowledge to the platform, as well as third-party customers outside of the GE traditional customer base can take advantage of the platform. A couple other things I've talked about: the edge, so the ability to operate. I think the term here is hybrid IT that we're using here at the conference, and so really it's about having a hybrid IT environment where we can run those analytics, build those twins where appropriate. Be it again out in the operational environment where you've got very high latency issues, or bringing that information back to the cloud and operating in the cloud. Lastly, just a quick comment before we turn it over is security and compliance. Those are issues that are very, very high in terms of priority for the GE businesses and for our customers. If you think about the regulatory requirements around who has access to information around jet engines, those are some of the highest standards that you have in the world today in terms of data policies, who has access to data management. And so we have a whole set of controls that we've developed traditionally around the GE businesses that we're now integrating as part of the platform. So it's the ability to track and understand how people have been managing, who's been accessing data, how that data has been updated, and basically doing a bunch of logging, as well as the traditional stuff around encryption and all the things you want to do to make sure that data remains secure in today's environment. That includes industrial protocols. So you want to think about the traditional IT protocols and firewalls that work with traditional IT data. We also have industrial data, industrial protocols. That's a whole different set of information and how that information flows. And so we've got firewalls that are industrially oriented and specific to the needs in the industrial space. So in summary, we're an app platform, truly a platform. So it's open. We have 40 different microservices available today on Predix.io. Only about half of those have been developed by Predix. We've got a bunch of those that have been developed by other GE businesses and then third parties. We have 140 analytics that are available there, and that continues to grow. And so it's basically a platform that will allow people to build applications that address industry-specific use cases. So that's kind of the overview on what Predix is. I don't know if you guys want to add additional comments, maybe? Sure.
And just to add to this, so Trip Partain, I'm the CT supporting the GE account from an HPE standpoint. So as we look from an HPE and partnering with GE around the Predix platform, three main things kind of surface up just from a general standpoint. One, of course, is as you look to power solutions at the edge, what are the types of compute capabilities that are required, and what are the types of environments is it going to go into? And as you guys know already, and as you heard from the other announcements with our Edgeline converged systems, they're really ideal for those types of environments and for those types of solutions. So obviously, from a partnership standpoint, we work to make sure that we're certified and can run all of the Predix software as well as other third-party software, which could be enabled at the edge for certain use cases. It could be part of the Predix stack. It could be one of your recent acquisitions, things like Bitstu or Wise.io, or could be a business unit specific application which has not yet been ported over to the Predix platform. Right? So we work very tightly with GE Digital on those sorts of integrations at the edge. And then in a hybrid IT fashion, if a customer has a mix of how and where they need to run things, some things are in the cloud, some things are on-premise, some things are at the edge, what does that look like? How does that get configured? Then also, how does that support work? And so being able to have our support services integrated with GE support services, so for the customer, it's seamless across what could be a fairly complex environment, mixing IT and OT, to make sure that we're still able to offer that, at the full level of service that a customer would expect from GE or expect from HPE.
All right, I'm going to breathe deep because this is a complex topic. Let's start at all the way at the bottom, the edge. What are you guys doing when you say you work with non-GE assets as well as GE access? What are you guys doing to kind of normalize and present to the business consumer IoT data that they can make actionable?
So, that's the whole premise of the Predix platform, right, from a cloud standpoint. When you think about running any asset, irregardless of GE owned or not, right, the whole point is the sensors that are embedded on that asset should be producing some sort of bits or bytes that you can consume and interpret, right? What you have after that sensor is then an industrial control system that is really the brains of how that asset performs. And what's missing is the analytics to tell that industrial control system what to action on. So what we're doing is that edge solution is to normalize the data that is interpreted by the industrial control system that then creates an action for that asset to do. Our solution is, hey, when you need to run something that's maybe lightweight or a fairly low latency mission critical action, that should run at the edge and it should be normalized based on the bits that come off of that sensor, irregardless of what sensor that is. When you need more time to process that analytic or that analysis, send that back to the cloud, use the compute power of the cloud, and maybe you can deal with a little bit more latency to get that answer back. and then make that decision again with the industrial control system. But our goal is that the bits and bytes that have originally come off of that sensor should be, irregardless of GE asset or not, still just bits and bytes that we interpret through our edge solution.
So let's talk a little bit more about that industrial controls solution. Is that a GE provided solution, or are you guys relying on the industry at large and the standards available and products available at that control point to collect the data, then you guys normalize it and talk to like TNS and how that plays into this whole solution?
Yeah, industrial control systems are an industry standard, right? Think of a nuclear power plant. There's an industrial control system that GE provides as part of our product offering. Similarly, our competitors in that same space would have their industrial control systems that they have applied to their own assets. And so this is already an industry standard. There's already policies and governance around industrial control system management. And so that's what we're relying on, is that those standards and those product offerings already exist. We're now applying the smartness and the intelligence with the edge solution to help that industrial control system make decisions. Right now, they're very reactive. They're binary. If this, then that, right? We want to give them, hey, if you start to see this, predicting what you might want to change or maybe make the asset do something different, that's where the edge solution comes in. But normalizing already has happened on industrial control systems.
So aggregation of industrial control solutions at the manufacturing level, is there a use case for that on saying, okay, we have two different operating environments or control systems that are related in the overall manufacturing process, and we want to add some analytics to that? Do you guys have those types of use cases, and does Predix offer that normalization across those control systems?
Absolutely. So take an energy utility company, right? They're probably producing energy in a couple of different fashions. You may have a wind farm, you may have a nuclear power plant, you may have water gen, a turbine, right? And so those all have specific industrial control systems based on the asset category or the asset family. And so what Predix is doing is allowing for that utility company to look across those three different asset classes and interpret, hey, what's the best power output and efficiency that I can get? And the basically the edge solutions will be applicable to those asset classes, but that's where the platform comes in. So when you actually build your application on Predix, it allows you to pull in those data sets to make a holistic view of your entire energy output for that utility company. And it can determine, hey, based on consumption, should I produce more water? Should I, turn the wind turbines or wind farm on to produce more energy out of wind? And they can make those declarations theoretically on all of those data sets.
Yeah, just to add to that a little bit, we have a piece of software we call Predix Machine, which is basically the mechanism to do that aggregation and to move the data back and forth between the edge and into the cloud. It also provides an operating environment where analytics can be run or can be developed in the cloud, pushed down to the edge, operated on the edge. So we've built in it's specific software that we have developed as GE. An important note here is that it's in use not only with our traditional GE businesses, but one of our marquee customers is Schindler. They're an elevator escalator company, right? We're working with them right now, and they've looked to us because they're looking at us to provide the software. They're running on their hardware for the specific elevator infrastructure. They have third parties that they're working with from a server architecture capabilities, but they've looked to us to provide that software layer, right? So there's clearly a need in the market for somebody to abstract up, provide an environment where those analytics can run, provide the connectivity necessary to move data back and forth, and aggregate that information. So it's very much real today, and we've got it in market with several of our customers.
And if I could quickly add, there's a proof of value that we did together with, and I can't say who the customer is, but you'll probably be able to figure it out. It's a large consumer goods company. They make a large amount of baby products, among other things. And so one of their factories, they had two lines.
Diapers.
Yeah, they have two lines that were producing diapers. And what happened is they would do, and this particular use case was around energy management. And so what was happening was they would estimate at the beginning of a year how much energy they're going to use. And if they go over or under too much, they get fined. So what would actually happen toward the end of the year, if they were getting too close on energy consumption, they just shut the line down, because it was better for them to stop producing than to go over and pay the penalty. And in that environment, there were already energy management systems. There were PLCs that were on the line. There were ERP systems. There was lots of data, but none of it had been integrated. And so what we did together was we pulled the data together, we looked at it holistically, and actually came up with an energy consumption per diaper. And what they actually found out was, even though they thought it was two identical production lines, one was twice as efficient as the other. Once you understand that, and you're able to gauge and estimate on a per diaper basis what your energy consumption is, instead of just running, and oh crap, we're getting close on energy, shut everything down, you can start to work between your lines. How fast am I running? How often am I running? Balancing your actual utilization of that energy as you're producing, still stay under the consumption, but actually have much more output coming out and not having to shut a line down, which seems kind of silly in today's age, that you would go, well, the best option is just stop producing diapers so we don't pay the penalty. And these are all systems that exist and have been pulling data, but not together, not looking holistically across and saying, okay, how do I define the problem, and then what can I do from an optimization standpoint to still achieve the energy levels I need, but now have many more diapers coming off the line. And oh, by the way, we also learned that one line is twice as efficient as the other, and now we can go make tweaks to get that corrected as well. So an example of existing systems may or may not have been GE.
Yeah.
Pulling that data together and then being able to use that and then automate that and then drive outcomes in real time as you then go to production.
So my background is the IT space, and you would think a lot of these solutions have been solved, and in some cases they have been in silos. But I think what we've got with the ability of cloud computing now and technologies to actually break through some of those silos. And even this consumer goods company, right? They've made acquisitions along the way. They've got different types of infrastructure, different PLC systems, different control systems that come from different vendors. They don't typically change stuff out. Right. I mean, when I worked at Microsoft, we would complain that small businesses didn't, turn their laptops over, until 5 or 7 years. Right. These guys hold on to this stuff for decades. Right. And so there's a lot of data that's trapped in there, or they've had very much serialized processes. And so what we're trying to do is we're trying to inject together some technology that allows you to aggregate that information, break down the barriers, and more importantly, create a platform. It's an open platform. So we'll be talking about a lot of use cases, but this consumer goods, I mean, it's not a GE business, right? It's a place that HPE's got some strength. So thankfully we've got a partnership with them. But this is not just about making our businesses more, it is about making our businesses more productive, and that Anthony spent a lot of time doing that internally within GE, but it's also extending it to our customers and to the world at large.
Yeah, so going along those lines, it seems like one of the big opportunities you guys have is bringing IT and OT together. These have been two separate worlds for such a long time. I come from the IT side. I almost never touched manufacturing, MES, SCADA, all of that stuff was somebody else's responsibility. I'm curious how you come together for kind of these, in a partnership perspective, for some of these joint exercises when it seems like nobody's in charge of bringing IT and OT together.
Yeah, I'll start with this one. And so what I started doing early on within our partnership actually is, if I've got an industrial company coming in to talk to HPE, back up one step. What we found, one thing is we have a lot of similar customers. And for us, we have a lot of similar big customers. And we don't talk to any of the same people. Right? I mean, GE really focuses on the operations side of the house, and then we really focus. So HPE has a lot of relationships in the C-suite on the IT side, and GE vice versa. So what we've started doing as customers start to look at how they're solving IoT problems is it's really starting up on both sides. You've got conversations happening on the OT side, you've got conversations happening on the IT side. So I started inviting GE operational solution architects to come to the executive briefing visits when we have the IT teams coming in. Because as much as I can say, oh, you know, BP is a huge customer of HPE and we've worked with them for X number of years, somebody starts asking me about upstream and downstream, I'm an IT guy. I'm going to glaze over and I'm going to say, wait, but let me talk to you about Edgeline, right? Because that's kind of the world I live in. So I've started bringing in the operational experts to have that business conversation. And then when you start then saying, okay, well, how do I implement this in my environment? Then that's where the HPE side comes in, because we're like, okay, well, you understand your standards. We understand the way your environment's configured. We've already got certified solutions working with GE at the development side. So we know which pieces from our portfolio we can pull from. We know which GE Predix components already run on there. So we're able to accelerate the IT side of it. But honestly, as an IT company, my goal now is to try to have the business and the operational conversation. Because if I'm trying to talk to any industrial about the technology, then I'm missing the point. Just like with the consumer goods company, they needed to figure out how to solve the energy usage problem, not which technology from HP is really cool that I can apply there. That was the how do I get this done piece. The real problem was, how do I solve this business problem that I have, right? And so for an IT company, it's a little bit more challenging, but that's what, you know, I'm really relying more on my partner to help me have this operational conversation.
And I would just parlay that and say that there's, on the opposite side of that, think of OT, right? And especially when you get into data sovereignty challenges, right? Generally, that has been solved by the IT community, aka HP. HPE has come to help us figure out, hey, what's the best way? Because a lot of the countries that we have industries in do have or are starting to create these data sovereignty rules and regulations. And so we leverage them to come in and help us figure out, hey, what's the best solution? What kind of hardware do we have available within the region? How can we work with Predix to deploy in region to manage or to meet those data sovereignty requirements?
Industrial controls have been kept separate from the internet for a long time for a very good reason, but now it seems like there's going to be this sort of inevitable merging when you're talking about IoT and being able to, there's clearly business benefits from being able to access and process all this data, but I also feel like we're opening up a whole can of worms and security risks, and on the IT side, we haven't had much success in terms of actually protecting systems and data. What happens now when I can touch an industrial control and shut down a factory or take a plane out of the sky or whatever? What are you guys doing on the GE side and also the HPE side to address these risks that is different from what's already happening in IT?
So a very simple answer to it, well, I'll start off by saying a couple of years ago, GE acquired a company called WorldTech. WorldTech's industrial grade firewall solution is aimed at solving a portion of that problem, right? And specifically originated post Stuxnet. So Stuxnet was probably the biggest industrial control system breach in recent history that caused tremendous impact. And so WorldTech's aim is industrial grade or industrial specific protocols, i.e. 62243, I believe. But they're expanding their compliance and signature set. And basically the solution is aimed at putting it in front of those industrial control systems so that data throughput that comes in and out, ingress and egress, is monitored and tracked through that firewall. It's slightly different than the IT house on the enterprise side, where we're dealing with your standard firewall port configurations and NACL protocols. This is more tailored to traffic patterns and anomalies and signature detection that are attacking industrial control systems. Is it a perfect solution? No. Is there a lot of room to grow, especially when you get into data encryption and transit at rest? But the real risk here is who can take control of that asset and cause detrimental impact to a mission critical environment. And that's where that solution hopefully comes into play.
Well, and it's similar. So what's very interesting, and this is another one of the synergies that we found via the partnership, is the way WorldTech approaches that is very similar to what you've heard between a combination of ClearPass and now Niara, right? But between policy management at a different level than just how do I configure the boxes and set up my network. It's a software-defined policy management. So back to your example, within the World Tech space, I could allow traffic to flow from left to right or right to left, but because I can do deep policy and packet inspection, I can have a rule that says I never accept a shutdown command from here to here. So I can be very specific to say, yes, I allow this sort of traffic, but these certain key critical commands we shut down and don't allow to come from any of these other sources except for, so you have the ability to be pretty precise about that within the World Tech space. And we found a lot of similarities with that in what we're doing in ClearPass and Niara. And I'm not going to say too much other than watch this space, and I would expect to see these worlds coming together sooner than later. And there's some real unique market opportunities if we get that right.
One last comment on this. We're technologists, but security is about people, process, and technology, right? And so we have people in place within GE. So so there's a whole incident response network and community and forums that are specific to the OT space, trust, ISOC. We participate in those. We've got the seat at the table as GE around that. So we understand that area. We also have Red Team members in Israel. Many of these guys are former military officers in the Israeli army. And so we're hacking our own stuff constantly, looking at Predix, making sure that we've got resiliency and security built in. So we're taking not only the technical on-premise approach around the edge with the customer, but we're also looking at it at different vectors, making sure that we're participating in the right communities, but more importantly, actually, trying to break our own stuff before somebody else tries to break our own stuff.
The last thing on that one, I would say if you went into most OT factories and they say they're air-gapped and they're not connected to the IT side of the house, 99.7% of the time, if you put a sniffer on the network, they're connected. Just didn't realize it. Somewhere along the way, somebody put something in place to allow an engineer to dial in from home at 3 in the morning. And to do that, they hopped across the IT network because that's the only way they knew how to make it work. So the idea that, and I agree that if you go, and even you go meet with the customers, and you guys see this even more than we do, they'll tell you it's air gap. They tell you the two don't touch. In today's day and age, they're always touching, not to mention the fact that people are walking around the factory with smartphones and USB, and the problem's really already there. It's just people aren't even watching it.
Well, this is where I come back, and again, I'm going to just take a liberty for another moment. This is where I kind of come back to the box huggers, right? Mentality where people think that if they can see it and they can hug it, it's secure, right? In this day and age, that's not true, right? I love to tell a story of my kid. These guys already know he's a Red Team member. He's fresh out of college, and his first 2 assignments were one with a mid-sized bank in the East Coast, and another one actually I think was a casino. And by Wednesday, in both those engagements, this kid who's fresh out of college had basically got into their network, right? The people who think they've got the sophistication around security in today's day and age don't, right? You really do need to rely, I think you need to rely on people who have the relationships that we do as tech companies and IoT companies. You need to rely on the experts. And I think we're looking at problems at a different level than people are. So I understand the concern about connecting the two, but to Tripp's point, they're already connected. It's just nobody's actually really looking at it closely.
Sure, and I get that. I'm curious, I'm wondering if there are new or different models, because we know about the IT security models and where they work and where they don't. If you try to apply that to OT or the industrial sector, are there different ways we should be thinking about it or doing things versus trying to take models that have known flaws and patch it onto very critical systems?
Yeah, I mean, think about your classic enterprise network diagram, which basically has the DMZ, which is walled off by 2 different firewalls, and then you do some sort of packet inspection within that to figure out, hey, what signatures are coming through, and can I identify something that is malicious, right? And there's a whole host of models around that basic structure. When you look at the World Tech solution and where we're getting to, it's actually it creates its own DMZ within the internal network itself. So you actually get to let me say this. One of the biggest challenges is network transgression when you actually do get in, right? Somebody gets in and they can transgress your network and get all around whatever they need to find more sensitive information. That becomes the biggest problem because it's sprawling. What WorldTech is aiming at doing is we have two levels. We have one on the higher level ingress, and then we have another one specific to the asset and manages that particular asset on the firewall level. And so if you plug a USB port, it doesn't get out, right? That traffic is inspected on the out. And then when it's coming in, and if let's say it does make it in past that second level, it is walled off at that asset. So only that asset's affected. So really the model is not so much about should I do a DMZ or not. It's really preventing network transgression if something does happen. Because today we basically just say, we're going to protect, it's kind of like an onion. We're going to protect the perimeter, right? And it's going to be layers until you get to the most sensitive data. The layer model that is applicable on the enterprise side is even deeper on the OT side, which is where WorldTech is trying to get to right now. That classic DMZ model, I think, will have to change over time. When we think about the platform and Predix, that's a different security model than at the asset layer, right? So those two will be different for the time being.
So going back off of security, because we just like to move fast, and who cares about security? Exactly. Let's talk a little bit about the compute model. This is A16Z Levine said that edge computing is going to kill the cloud, and you guys are kind of coming back with something a little bit different, which is edge computing in combination with a cloud platform. So let's talk through the management of that, because it sounds like what you're giving me is a PaaS platform to develop my applications upon, and that control plane is pushed down to the edge. Practically, what does that look like from an infrastructure perspective? Are you guys providing all the edge compute, software, etc., the data center assets, and managing that as a managed system within my environment, or is it a combination relationship between IT? What's the operating model of that?
Yeah, I mean, it's Trip and I were just joking a little bit. It's kind of all of the above, honestly. Together. Edge compute eating the cloud, I think, is an interesting concept. I guess my spin or my interpretation would be that it's a hybrid, right? There are use cases that are going to require the compute capacity of cloud. And there are low latency data sovereignty reasons, well, maybe not data sovereignty, but low latency reasons why I need to make a mission critical or life impacting decision on the edge, right? So it's really use case driven. In my opinion, when you look at where edge computing is going, it will get beefier because the analysis to do predictive decisions will need to be more computational, more compute intensive. And so it will get there, but there is always going to be a need for the cloud to make a bigger decision. Now, when you get back into like an application or a UI, that's where I say it's kind of all of the above together, because eventually you should be able to run an on-prem or a local application if you want to manage, let's say, a massive wind farm. But if you don't want to do that locally because you don't have any data sovereignty reasons, or you are cloud, maybe you want to run that in the cloud environment, those data sets should be available for you to make that decision, right? So when you do the analysis and the decision making on the edge side, that data set should then push to the cloud environment so you can run a more global application to manage a more holistic view of your asset base. Does that make sense?
If your asset is complex enough, and I know Dr. Tom is going to get as much compute power at the edge as possible, just ask him, right? And he'll tell you that, which is fine. But when you start talking about high performance compute and some of the real neural capabilities that are necessary for these massively complex assets. I mean, we were talking a little bit last night about one of your plants in Greenville and just the size and scale of one asset that you deal with and the amount of man and machine power it takes just moving that one asset through a plant. Something that large, inside of it, you're talking about tens of thousands of sensors, right? And so if you're trying to recreate that sort of asset in a machine fashion, right? There's different levels of compute that are going to be required. And the other thing and this is a little odd for somebody from the technical side of the house or whatever, but there's a lot of backwards, and I don't mean this in the wrong way. OT technology, a PLC is like a printer from 40 years ago. You know, open up and look in the circuit boards, right? So they've got a long way to go before suddenly they jump from where they are now to the latest in IT, right? There's going to be, and the machinery within those factories and industrial settings, many of them still have 20 or 30 years on their existing lifespan. So you're going to have to sort of retrofit and pick the pieces. I look at that industry and it reminds me of where ERP was 30 years ago, right? Or maybe 30 years is too far, but you had these DOS-based systems and you had a GL and somebody built a general ledger and somebody built an AR and somebody built accounts payable, and each of those were sort of independent solutions and they were huge advancements on their own. And then somebody stops and goes, I'm going to put all that together because there's so much synchronization that needs to happen. And you had a 20-year wave of that sort of working its way through. And that was finance people that are actually fairly technical, right? On the industrial side, you've got a similar wave that's got to come. And you've got lots of distinct silos that kind of have to come together. And it's going to take a varied combination per customer, per industry, per use cases, mixing technology in the right places to solve it. I went to a factory with GE in Modesto, California, where they make filters, oil filters, fuel filters. If you drive a Chrysler, a Ford, a John Deere, you've all had those filters in your vehicle. You just didn't know it was all coming from the same place because they brand them. Those are factories that just having a cloud connection to connect 3 or 4 things is a huge advancement, because they had no automation at that level. Now, there's plenty of mechanical automation, but not technical automation, right? When the filter came off the line and it would no longer had cellophane on it, you hit the stop button. Where's George? Anybody seen where George is? So they start making the call. Yeah, he's 3 buildings down. It'll be 30 minutes. The line sits there for 30 minutes till George can come and put a new cellophane roll on, right? And that seems odd, but that's not like a one-off. So each of these have environments spread out that may or may not even be connected in a lot of ways. So what we've been working on is how to create a set of standards that can then get put together in the right combinations depending on what the customer needs, depending on the location, depending on the industry, the regulation, the sovereign, etc. Right? So all the examples you gave are configurations that we're probably talking with joint customers about right now already.
And just a finer tooth example, take the aviation industry, right? 10 years ago, we collected 3 snapshots within a flight: takeoff, cruise, and landing. That snapshot equated to about 5 to 10 kilobytes of data. Easy enough to compute. Fast forward to where we're at today, we can take we get about 5 gigs, or 5-ish gigs, and we take a snapshot every second throughout the entire flight. Now, when you're actually in flight, edge computing makes sense because you want to make low latency, real-time decisions. You probably aren't connected to push things back to the cloud, and you want to adjust the current flight. But when you multiply 5 gigs of data per flight, 30,000 flights a day, 15 airlines across the industry, and all of their entire fleet, that amount of computation doesn't necessarily need the latency, but it needs computational power. That use case, to me, unless you're running your own data center, which may be true, seems like a use case you would push to cloud and have the analysis done there. Right? So those are examples where low latency, limited data sets, real-time decision making makes sense for edge. But when you expand out to the data sets we're talking about in the petabytes, cloud seems to be a viable option today.
So I use that same example in many of my presentations when I talk about IoT. So to give you some real numbers, so if you take all of the Boeing 787s globally, all of the different carriers, it's about 40 petabytes a day of data using the GE NX90 engine. If you use that same, assuming that same kind of data feed off of just Southwest's fleet, which at the time when I put the slide together, 607 planes. 607 times 2 engines per plane comes out to be 256 petabytes per day for Southwest Airlines, one company. So just think about how you're going to consume 256 petabytes. So just give you some specifics there.
No, those are good data points. I'd love to see that page too.
So I guess the next question is, I love the ERP example because that was a great blast from the past, and a lot of that heavy lifting had to be done internally. So you had all these MRP type apps as a result of it, and eventually SAP, PeopleSoft, Oracle, and we have what we have today, which now we're trying to transition that to a cloud type model. The advantage that we have today with OT and IoT, IT combining is that we already have the cloud today. So coming into this industry fresh, I'll look at it and say, you know what, I'd just like to have an abstraction where I guess the simplest and dumbest way to look at it is look at AWS with their Snowball Edge and say, ideally, you know what, I'd love to just plop a bunch of Snowball Edges down in my the example that they gave, Snowball Edges down in my wind farm, do some Lambda code, and whenever I do need to upload that stuff to the cloud, you know, I ship a node off to AWS and ingest it. Help us kind of I'm not going to use the word double click, so let's say help us go deeper into that and pull back the layers and understand the breaks and complexity, and when fantasy kind of meets real life, where's the market in maturity of when that abstraction breaks, and when is the example of 10,000 pieces of 10,000 sensors for a 4-node cluster just isn't going to be enough.
Yeah, well, and then the other thing, and actually I'll start with your wind farm example, and then you guys can correct me, but I think we walked through this one enough times, I feel good about it. So even in that example, the use case where I want to collect all that data and then ship it off is a certain use case, because with a wind turbine today, or at least the way the ones that GE's now rolling out, they're looking at all of what's going on in the weather patterns at that moment, and it's self-adjusting and shifting its positioning, the level of the wings on the fan to maximize the output at that point in time. So for that part of the compute, you've got to have it all right there locally, because you're making real-time adjustments based on what's going on. And if you've got X amount of these turbines spread out over acres, what's happening in the front corner of this one may be different than what's happening in the back, right? So again, it's a use case driven model where there's certain scenarios where I need enough of that compute power there to drive certain activities, because there's a certain efficiency in trying to maximize my production that I'm trying to drive. Now, a condition maintenance looking for anomalies across a larger fleet over a larger amount of time, that becomes a use case where collecting the data over time, shipping it off, and being able to run it through, I don't know what I'm looking for, but I want somebody to run correlation analysis through all of this data to see if there's nuggets that I'm missing, then that use case really matches up to the collection piece, right? So
and then you put another overlay on that. Is it winter or is it summer? If it's summer, oil or energy prices are up, I may want to push that wind farm a little bit harder. I might want to give those wind turbines a little bit more latitude to push harder, because I'm going to make more money. Yeah, I'm going to have to move but you can do the real-time analysis. I'm going to need to move my maintenance window in, right? And so you want to do that analysis to determine is it worthwhile, or maybe you shut some of them down because oil price or energy prices are down, right? And it's the winter season, so we want to push that maintenance window out. So it's a lot more than just a couple of Lambda calls, right, and pushing data up to the cloud when you think so. There's a lot of work that needs to be done there on-prem.
The other thing, too, and we'll wrap it a little bit, I think, is your objection of dropping in some snowballs from AWS is what we're trying to aim at, right? The whole point of Predix platform is to make it easy for the end user to build their own custom applications, very simplistic. right? So we're trying to abstract away a lot of the complexities of the IaaS and the PaaS portion so that you can focus on the data analytics, the data management, and ultimately the applications that come out of it, right? We started to build those functions that you can just call in, and that's where the microservices come in as well, and reusable analytics. So again, you can start to plug and play these components through an API layer that allow you to create a more sophisticated app very quickly. That's our ultimate goal as well.
Well, we're going to bring it to a close here. Thanks very much, Trip, Anthony, and Getas for exposing some of the GE Digital IoT. We will be back very shortly with a smart cities focused IoT, but we'll take a quick break right now. Thanks very much, guys. All right, we're back again for the third coffee talk of day 2. And this one is Nigel Upton talking to us about smart cities and the future of IoT and what it's going to do for the citizens and the governments.
Can you guys hear me okay now? Oh, well, wonderful. Thank you. I'm just admiring the shiny Dell laptop sitting over there. Come on, who's got no class? So, my name is Nigel Upton, and I look after our universal IoT platform, and we essentially do the data enablement. What does that mean? Typically, we work with a whole bunch of different suppliers who are producing devices, things, and in the case of smart cities, the citizens actually get to choose what type of services they want, in the theory that the elected official would like to remain elected. So it varies dramatically country by country, region by region, city by city. Places like India, women's security is a big, big social issue. So that was the first solution that we built, going out across 400 million people in India with different devices. They look a little bit like these sort of things, and it's got in there a GPS and a LoRa connectivity. Could have a SIM card, could have whatever you wanted. And these sort of devices, they have a panic button on it, and if somebody feels threatened, then they press a panic button. And that then, depending on where they are, they have a guaranteed response within a certain number of minutes from a security company. It also starts to get a little more sophisticated when, if you also have video surveillance, the video cameras automatically turn on in the surrounding area, and you're starting to see just a greater and greater level of sophistication of the type of services that are being rolled out in smart cities. So, you know, the obvious ones of street lights and being able to control street lights. Street lights are interesting because it normally is about 35% of the total energy budget for a city. They spend a lot of money on lighting. And if you can control that and reduce the amount of, reduce the energy consumption, then that's a good thing to do. So that's what our platform helps them do. At the same time, you can make lighting much more intelligent, proximity-based, so that it'll go on and off as and when you need it, rather than just remain on all night. There's various things you can do with streetlights that are quite interesting. And if you look at the demo site that we have, as you walk in, you'll see a street light, and on top of it, there's a bunch of sensors. That includes a video camera. It includes a sound detector for things like gunshots. There's just a bunch of sensors that they're using street lamps more and more to be able to sensorize a city. So the development that you're seeing on just the different types of sensors, and there's so many innovative brand new companies coming out with new things. Our job is to be able to connect these new things over any type of network, whether it's LoRa, whether it's Sigfox, whether it's cellular, Wi-Fi, and then be able to take the data, build city command centers, or if you're from the telco world, a NOC, a network operations center, but build them for cities so that you integrate in video surveillance together with smart trash, smart lighting, all the other services that are being rolled out. So interesting times.
So we often associate Internet of Things as being we're collecting a bunch of data, and sometime later we're going to do something useful with it. So I'm really intrigued with the panic alarm as sort of sitting in that the more immediate connection to the citizen. Are there other initiatives you've seen of that very immediate connection?
The panic button is the most obvious, and I think from your previous speaker on the industrial IoT side of it, that is much more immediate. It's if something goes wrong, somebody's going to get killed. So there's a sense of urgency. Whereas we tend to deal with more widespread devices that you can deal with latency of a minute or two, and that's okay. It's not going to affect human lives. So whether a trash can is picked up in the next hour or the next 5 hours, nobody's going to die. Well, at least not in my neighborhood. It depends on the use case. It's also interesting just watching how the connectivity evolves. If, for example, you're a phone company, then you might believe that a cellular connection is the best connection. If you're not a phone company, then you don't believe that. Funny that thing of if you have a hammer, everything, well, you know what I mean. We see a lot of aggression in the low-power wide area network deployments, LoRa particularly.
LoRa and Sigfox for those, and that's the panic alarm would be coin cell operated and would have a single coin cell with a 2 to 5 year life on it,
Exactly.
rather than having to be recharged every day
Exactly.
as you would if it had a cellular.
Yeah, and the sensors now are getting embedded in products. As IoT becomes a bit more mature, think about things like bicycles or backpacks. The sensors are now being embedded in there, and they have typically a GPS device and either a LoRa type connectivity or what will soon be narrowband IoT, so that the days of having your bicycle stolen will be behind us. So the days of not knowing where your backpack is or tracking your beloved one as they wander through the woods across the Pacific Coast Highway, you'll be able to track them. Now, whether you should or not is perhaps an ethical question, but anyway.
Like that bit just around what you should and shouldn't do and whatever. That's one of the areas I'm interested in, and I got sort of a few different things and bouncing around my head about it. But it's really on the data. Who has access to it? How do you expose that? And then how do you, and in some cases where it's relevant, anonymizing that data. So I guess starting off, like, if it's, say, security company data, it's panic button type thing, whatever, then that data that's that company that's doing that.
Right.
And it's their data and they can do whatever they please with it.
Yep.
But if I'm a city doing it, say I have transport data sets or something like that, or the trash can pickup, that sort of stuff. If it's my local council, government, whatever, is the one who's actually doing the data collection of their network, what are you seeing in terms of the way they're approaching exposing that data, making that data available to other people? Like, do you see differences in approaches where some councils say, well, they say, that's our data, we hold on to it, it's tough. Or other ones are like, here's these random data sets and we'll make them available to whoever wants to try and figure out cool uses of it.
Yeah, it's a really interesting question. There's a lot of legal issues with it as well. In the case of trash cans, that's relatively straightforward. There's not too many parties involved, and if you wanted to anomalize the trash can route data, that type of stuff, I could see that being maybe of value to other trash companies or other cities. And there's a lot of sharing of best practices city to city, so you could see the anomalized data being used there. Where it starts to get a little more tricky is on things like connected cars. And who owns the data on the car, and is it the car company, is it the component provider, is it the service shop, or is it the consumer? There are pretty strict rules on where data is allowed to sit in terms of country barriers, and so data sovereignty is quite well defined, but data ownership is not well defined at all.
And it's one of those things as well where maybe you think you anonymize the data that you expose, but then, like, I think the case was, I think it was Uber that published some data a few years back on New York City, and people could pretty quickly figure out which celebrities were, what their traffic things were based on. Well, they knew that their start and end point. They go, okay, well, I know that X celebrity lives at this location. There's these Uber rides going to and from there.
Right.
That's probably that person.
Right.
And or it's that thing where, and even if there's enough data, I can glean patterns from it. So like the traffic patterns, it might be really interesting from a city trying to figure out how do I manage my traffic congestion? How do I do things like, what can I find out about when does Alistair drive past such and such location? Where is he? Maybe he's not actually going to work like he says he does when he's going to work.
I hear you.
I work at the bottom of my garden, so that's not so much of a problem. But that fundamentally is about how the data was anonymized. It was anonymized lazily by Uber, that they anonymized the user rather than the trip. And that's the classic problem of anonymizing data for publication. But it's not an intractable problem. It's simply a establish a best practice and publish and communicate how to do that.
It's one of those things as well. You're trying to anonymize the data to protect people, but you're also like, how do I anonymize it but keep it useful?
Right.
Like I can with trip data, I take out the user identifying information, but I actually really need to know where their start and end points and their routes were, because that's actually that's for the interesting stuff. But it's also, how do I balance it out? It's like in network packet captures or something like that, we might want to anonymize our IP addresses, but I have to be consistent in my anonymization so I can actually see what are the flows. I guess what might be interesting as well is what you're seeing with the way different countries are thinking about that as well. Just in terms of, are some biasing to an open approach, others biasing towards closed? Just interesting to see what you're seeing on a regional basis, or is it just really depends who's running the show in that particular town?
Well, remember that the phone companies know exactly what you're doing, where you are. Even they can turn the phone on if they want. They can turn on the microphone. They can turn on the camera. In fact, some 3 acronymed government agencies do exactly that. So I haven't seen, at least on the phone companies, the issue with anonymization of data, even though it's quite widely used. So telcos know how to do this, and we've been working with them for the last 30 years. It's the newer stuff where the German view on privacy is quite different to the American view. And it's also a generational thing. My kids' expectation of privacy is very different to mine. They post stuff on there and you're looking at it going, wow. So we've seen, particularly in Asia and in parts of Western Europe, very heavy emphasis on data. Brazil, for example, very strict laws on sovereignty of exactly where that data is allowed to reside. The same in a lot of the EU countries. But those laws are in place and they're already enforced. It's the anonymization that's going to become a lot more tricky to do properly, as you pointed out with Uber. We already see this in agriculture, and there's a big fight on who owns the data for precision ag, and is it the producer of the actual...
Well, if I own a John Deere tractor, I'm not even allowed to attempt to repair that tractor. John Deere just licenses that tractor to me.
Yeah. But that's what's happening. Yeah. So I don't know what the answer is, quite frankly, but it will change. And the connected cars, I suspect, will be producing so much data about how you drive, and there's stuff already being fed into insurance companies where right now you kind of have the option of plugging in an ODB2 port connector, and then you can analyze, your driving.
I mean, I'm sure we've all been in a hire car, and we're all wondering, if I exceed the speed limit, does the hire car company know that I'm doing that? It's like, yeah, probably they do.
Yeah.
I was just going with the flow of traffic, by the way.
You must have a sense of humor. Yeah, I've seen your rugby team play. Sorry, so I'm kidding. At least there's nobody from South Africa here. Oh my gosh.
I don't think so. I think we're all right on that front.
Oh, good. Okay.
Maybe we should swing this back to smart cities somewhere along this conversation. Are you seeing the sort of instrumentation of their infrastructure leading to different ways that the local governments are actually setting policies, setting social policies from how they're instrumenting their population and their constituency?
So technology is being used in at least 2 ways, one of which is getting the opinion of citizens. So you see a lot of the Twitter fire hose feeds, you're seeing the social media sentiment analysis stuff, and that's quite useful for deciding what type of services that the city wants to launch. On the other hand, we build these big command centers for them, where as they digitize more and more stuff, from trash to lighting to panic buttons, video surveillance is huge now. And the more and more incidents we have all over the world, the more and more people want to be able to get a grip on video surveillance. So that's accelerating quickly. It seems to be, normally the first is around citizen safety and security. And that tends to be the top button that keeps a politician in power, but also the video surveillance stuff, it's interesting now because you can tell when a vehicle leaves a lane, you can tell when abnormal behavior happens, and when you start combining a vehicle leaving a lane and a gunshot going off, you can instrument all of that and know exactly what's going on through a command center.
I was thinking of the more longer term than the immediate reactive.
Right.
Just thinking through whether there's things about traffic patterns or whether there's city planning changes around that instrumentation. I guess the focus is more the new and shiny is the much shorter term, much quicker turnaround on data than we've previously seen.
It is to some extent, but traffic patterns particularly because cities are designed for transport. And the new mega cities getting built are quite different to the older cities where, paved over cow paths. So the traffic analysis, particularly through video analysis, is getting more and more interesting. They're also sensorizing roads so that you can tell exactly what the traffic is doing at any given time. The traffic piece is probably the highest value to most of these cities. But they're also implementing, smart parking is relatively straightforward to put in because there's statistics in some of these cities of 30% of their traffic are people driving around looking for parking. So if you can get rid of all of that and pre-book parking and automate all the payment of it and link it to cameras that'll take your license plate, and then you just charge for exactly how long you're there, get rid of that concept of having to pay a meter and pay a meter. So all that stuff is happening very quickly. They also, any city wants to be able to drive some financial return as well. So that's why this smart lighting is quite popular because you reduce costs. Smart parking is popular because you can drive revenue from it and arguably make it more attractive for people to come into the city. The same with traffic. And then the safety angle see a lot of traction on that.
So what are the HP products that are actually involved in this? Because so far it's been a very generic discussion about what smart cities are and could be, but what are the specifics of what HP is doing in smart city?
So we build a application enablement platform called the Universal IoT platform. And this Universal IoT platform allows us to be able to connect to any device over any network. So we don't build the device. And we use whatever is the appropriate network, whether it's LoRa or cellular or Wi-Fi, whatever it happens to be. We suck the data off the devices. We put it into a common model. We use a standards-based model called the 1M2M model. By the way, the idea of having a standards-based platform is quite important also for security, because the 1M2M defines how the data is encrypted, how the transportation between the device and the platform is done, just exactly how that is encrypted and controlled, and public and private license keys and all the rest of it. So we take the data, we do the analytics on it, we do the mashups of data with other data sources, and then build microservices like smart parking, smart lighting, all of that type of stuff. We build the application layer, and we control the device through, if any of you are familiar with Jasper from Cisco. So Jasper is all built on HPE technology. So we do all of that connectivity management to control the devices, pull them in and out of service, basically do the digital twinning of the complete network and then control the network. So we essentially take it from once the device starts spewing out data, it comes onto our platform, we take it from there all the way up to the applications.
So I'm curious with the Universal IoT platform. So I'm familiar with, say, mobile device management or endpoint management solutions, but I'm curious how you manage IoT, I guess, traffic and management across all of these different types of connectivity, especially the new ones like Sigfox, LoRa-based connectivity. How does that work, that you get that data and work on that actual management?
Sure. So usually it's going through some form of gateway. And if you're using LoRa, then it's normally a Semtech chip in there in the gateway. And we have that gateway talking to our platform. And so we connect over whatever mechanism it happens to be, whether it's LoRa or satellite or, quite frankly, we couldn't care less. We've repurposed a whole bunch of our telco assets to do the connectivity management. So we've built out networks for these for the last 20, 25 years. So we know how to provision a device and how to control it and how to clean it and wipe it and all the rest of it. So the through over-the-air updates, we do the SIM management pieces of it, the provisioning of SIMs, the dynamic changing of SIMs. So we're very, very familiar and comfortable with that space. And that background gives us the ability to be able to really understand all sorts of different types of networks, not just cellular or not just LoRa.
And also I was wondering from a practical perspective, with all these different types of connectivities and all the different types of use cases that exist for smarter cities, how do you kind of think about how to align these connectivities to use cases? For instance, are there certain types of newer connectivities that are better for, say, these alert type systems or better for, say, trash can or utilities management in comparison? What tends to be used most for what for the top smart cities use cases?
So for something like a trash can, essentially what the city told us is we need to be able to have a device that'll go in the trash can and last for the life of the trash can. Turns out that a trash can life is about 5 or 6 years. So they wanted something that will measure the depth of the trash inside that trash can, and they wanted it to last 5 or 6 years. So in that case, LoRa was a good technology because it's very low power. It only is taking data once a day or twice a day or once a limit is reached, so it's not very chatty. Embedding sensors in stuff where you're never going to dig them up again. Battery life is key, and you will choose some type of low power wide area network for that, whether it's LoRa or soon to be narrowband IoT, but you want something that's very, very power sensitive. It's different to the other thing is the length of the waves and how deep you want that to reach. If you're buried in the basement deep in, say, Tokyo, you need to be able to have a network that's going to get through X number of concrete walls and be able to penetrate. So that'll also help select the type of network technology that you use. Turns out LoRa is quite good at that because it's quite a long wave. In other cases where the devices are a lot more chatty, it could be video surveillance. And so you're going to have some quite big data files coming through. And in that case, you're either going to have it wired over Wi-Fi, or you're going to stick a SIM card in there and negotiate with the operator a decent rate and decide what you're going to upload and what you're going to download. But that device is dramatically different to a low energy, beacon type device. So it really does depend on the type of device it's almost as though it's a natural selection of the appropriate network for that type of device. From very low energy, not very chatty, small bits of data, through to video feed, which is intense. And so you will have to choose the right network for that type of stuff. Yeah, we get asked a lot of retrofitting questions as well when you come and retrofit things like electricity meters, gas meters. We spend a lot of time on this in Japan because of the structural challenges of having to go quite deep underground. Plus, because of the way it's designed with earthquakes and things, there's some fairly solid foundations in there. So, you really do have to have penetrative waves to be able to do the reading that you want to read.
So when we think about all this smart infrastructure that's going to be there for the purpose of city services and things of that nature, there is the potential we talked about earlier, IoT devices in backpacks and bicycles and things like that. I think of, as a parent, having the ability to securely subscribe to a mesh infrastructure that can capture the geographic data of my kid's backpack. I can make the hopefully decent assumption that where my kid's backpack is, my kid is. Not a fair assumption for many families, but we could even see the point of some of these integrated devices in clothing, in reusable things like shoes, belts, that are more likely to be more or less permanently attached to the kid. But the thing that I'm concerned about is while all this metadata about where that device physically is in the geography, that it comes at the price of privacy, and or in order to subscribe, I have to be inundated by adware. So is it going to be something that citizens of the community would be able to use? Part of their tax goes to cover that, so you don't have to be ad supported, and that we would have sufficient encryption in place that my kids' data only gets seen by me and the people that I want to allow to have access.
On the privacy side first, and being able to put around geofences of things that, yeah, my kids objected to open surgery where I wanted to insert it. They said no for some reason, but I mean, it's a real issue for parents. I think parents are prepared to make different sacrifices than kids. And once a kid hits 18, then are you still allowed to track them? I mean, there's a lot of ethical questions in this. And but if they're under 18, then God damn it, they're going to do what I want, and I'm going to track them. Or if they want to drive my car, these are the conditions under which I'm going to put a geofence around where you can drive, and how much power I'm going to make available to you in the car. All that's configurable now. But on the privacy thing, I don't think it's been worked out, quite frankly. I mean, as I said right at the start, just because you can do something doesn't mean you should do it. If it's the safety of your kids, then for me, I would do it. But it comes down to individual choices and different cultures as to what's going to be acceptable. So, I mean, data is encrypted, and there's so much data about you out there anyway. As I said, the phone companies have got your data, and they do a reasonable job of protecting it. I have no doubt there are going to be some exposures of data, and it's going to take a few crises for things to actually get done properly. We adhere to this idea of the 1M2M standard, which means that the data is the security of the data is forced by the standard to be encrypted, and public and private keys, that type of stuff. So some cities are attracted to that. Other ones, whether it's naivety or whatever it happens to be, a bit like the UK Public Health Service with all these XP, wondering why they get hacked with ransomware. When you've got, you can't cure stupidity when it comes to security. You can only have case after case, and then people are forced to do something. I suspect there'll be a lot of mileage out of security on this, because I don't think people have figured out the full extent as just to how much information is going to be exposed. As I said, we use the 1M2M model to be able to answer that question, but there's hundreds of IoT platforms out there, so I suspect bad things are going to happen, and then it'll get fixed. Sorry, and the second question was on?
It was once that data is secure, there's some way for us as the citizens that we're theoretically paying for this infrastructure through taxing, that we would be able to take advantage of that for personal use, i.e. tracking where our kids are. That I'm thinking of grade school age, that right. I think in most cultures you would probably figure, okay, in today's societies, yes, I want to know where my kids are. I may not watch what they're doing every day, every hour of the day, but if you're late from school, part of the geofencing piece, I expect you home by X o'clock. Right. You're not. Where are you? Yeah. You're not going to have the ability. I mean, today we have the cooperative mesh networks like Tile. Right. Right. So I throw a Tile in my kid's backpack, and assuming that there are other Tile users that have decided to share their bandwidth and integrate with the Tile network, I might have an idea of having, a 20-meter radius of where they are. If we're going to have smart cities that have this capability as part of its native functionality because of everything else that we're doing that way, being able to take advantage of that in a secure way, not just from the data integrity, the data security side, but also I should be the only one that gets to see where my kid is, those aspects.
Agree. So it's not a technical issue. I mean, it's an implementation issue, and that's why it's got to be taken seriously. But I suspect hacks will happen, and then it'll get taken seriously. It was interesting when we worked with operators as to, if you want to track your kid and you want to be able to geofence and put in boundaries as to where they can be, there's some simple stuff like checking in and out of the bus, and it's easy to put wireless readers in there, cheap, LoRa-based networks on the bus, so that when your child got on the bus and when they got off the bus. we found the price point to be about $2 a month is about what people would be fine paying for having a device that I know where my kid is. I'm not going to pay $30 a month, but $2 a month to track your dog or your child or whatever it is that you want to track. That seems to be a reasonable price point, and that's without adware. So that is just you having your portal, being able to understand your data and see where things are. But that price point, it's tough for some of the operators to get down to that level, because for this, the network cost for this, we built them for AT&T, Verizon. It cost about $16 a month for that operator to run a network and provision this. Voice, data, 911, and there's big expensive billing systems from companies like Amdocs. This is not cheap. So for you to get down to $1 a month, and if they charge you $2, we're building these networks for them, these brand new IoT-only networks. They strip out all the stuff like voice and 911, or get rid of all the billing stuff. You can make it cheap. So we can get it down to about a cost of about $1 a month, and then the customer would pay $2. I think that's a reasonable price point. But I mean, be interesting what you guys think. I mean, what would you feel willing to pay for putting a tracker on your dog?
If I thought my dog, which I don't have at the time, was as important enough for it, then I'd spend more than $2 a month. Yeah. Especially if I had one of those dogs that was a fence jumper, and I was always concerned about it. Absolutely.
Yeah.
My grade school kids, I'm not going to be as worried about as I will when they get high school and driver's licenses, and that their circle of where they're going to roam increases manifold, and then it becomes more important to do that, and there's more value in that. You hate to put any cost around a life, but there is
right.
You have income and you have expenses, and you have to be able to balance the two one way or the other. But the idea that you're stripping out all of the unnecessary functions for that end device should theoretically lower the costs involved in provisioning and maintaining. And again, if the mesh, the network that's required for the community devices to report in is already in place, then theoretically you shouldn't have to necessarily bear the cost of that infrastructure if the burden is already in place for the mailboxes, the garbage cans, the electric meters, all of that. Then it becomes a convenience piece that people, I hate to say that it's people of means can choose to do that. I also grew up in the 70s and early 80s where my parents didn't see me for days at a time, it seemed, and apparently having no tracker was just fine, and I made it this long.
I tell you, when your kids, talk to you and say, "You mean you didn't have Facebook when you grew up?" And you're going, "We had a stick."
But let me introduce you to Kick the Can.
Exactly.
That's a true example of survivor bias, though, right? I made it. I'm just fine. Well.
No, but it's true, though. I mean, anyway, our little protected children these days. Oh my gosh! Could you imagine back at your high school or university having corners you'd have to go to if somebody said something offensive? Oh my gosh! Anyway, different world. Yeah, it's finding the price point that will drive the adoption, and we always tease our colleagues in India for Indian price points of how the Indians invented the number 0, because that was the price they'd like to pay. And there's the price points in India are so different to Western Europe or the US, and the US still has the most expensive networks in the world. I mean, US customers for cellular pay more than anywhere else. By quite a big factor. I know it'll be interesting to see how the network continues to evolve with the help of Google as well, rolling out new services like Google Fi.
All right, I think we're running out of questions for you at this point. So we'll.
I was sort of ruminating another one in my head, but it's not properly formed. I'll track you down later.
All right. Well, so thank you very much for sharing that.
It's a pleasure.
Some great perspectives. We will be back at 1:30 for somebody's talking to us at 1:30 about hyperconvergence and composable infrastructure. So.
Who is that? Who is that? Whom?
That's Rick Lewis and Paul Miller, and oh yes, that new stack stuff that was being teased in the keynote yesterday. That looks fairly interesting. So thanks very much, Nigel.
Hey, my pleasure, guys. Thanks for listening. Cheers.
Deine story, but my son's basketball team had an event out here.
Yeah.
And they all convinced me to load up in my RV and ride from Colorado to Vegas as a team bus. And I have a TV in there, and they played NBA 2K the entire way. They had a ball.
So we're just down the end of the strip of the Oasis.
Yeah, I think that's where
we're going to get big race.
All right, we're back with the coffee talks here at HPE Discover in Las Vegas, and joining us for the next. How long have we got you for, Rick? We've got Rick for an hour, and we're probably going to have Paul Miller join us partway through to add. So I'll hand straight over to Rick to get started.
Great. Thanks for coming to Discover, and it's good to see a few familiar faces here. I've spoken with you on various occasions, so I really appreciate your interest and all of your writing on the things that we're doing. So I'm Rick Lewis. I lead the Software Defined and Cloud group. That's where we do our products that have software as the primary value proposition or are mostly software. As you probably have heard now through the various sessions here at Discover, we have really gotten laser focused on our corporate strategy around three key pillars. The first is around making hybrid IT simple. The second is powering the intelligent edge. And the third is providing the services and expertise to help customers transform their environments and deal with digital transformation and enable digital transformation. So that has enabled us in the last year even and a bit before that to really make some pretty big, bold moves. You've seen that as a company. Some spin merges, some divestitures, which for a while I think people were wondering, hey, what's going on? It seems like you're just getting rid of things. But the answer to that is actually there was a method to our madness, and that was so that we could enable ourselves to get more aggressive around those three key strategic pillars. The one that is most near and dear to me is the one in making hybrid IT simple. So what I thought I would do today is just give you a little bit of a, here's where we're at on the things that we're doing in software-defined infrastructure and our hybrid IT management software space. And maybe I'll talk for, 15 minutes or so, just to give you kind of the high level of what we're doing. And then I'll kind of go into Q&A and we'll see where we end up from there. So to make hybrid IT simple, it turns out takes a whole lot of software. And that's what we're working on in my group. And the way that we deliver that software to customers is primarily through integrated appliances. So hyperconverged device is obviously a software-defined infrastructure element, a lot of software in that. Made a bold move here in this last year. In fact, I'll summarize the three. Hyperconverged, our Synergy Composable platform, and something that we're talking about for the first time here at Discover, which is something we call HPE New Stack. It's not a branding. It's more of an kind of a project name that we've given it for what we're developing. And those are our three key vectors that we're driving, if you will, around making hybrid IT simple. So on the first of those, the big news is SimpliVity. We closed that acquisition in February of this year. The team and the technology fit like a glove with what we were trying to do with Hyperconverged. As many of you know, we have our own HC380 product that we're delivering, where we had put a lot of investment into simple user experience, ease of deployment, capabilities like that. And SimpliVity had spent most of their time growing an enterprise data services platform that's fantastic at integrated dedupe compression, backup, WAN optimization, all of the things that you dedupe and compress for and provide those industry-leading storage data services was really their background, and they had been kind of moving up the stack to more of the user interface in that. So putting the two together just made a whole lot of sense. We have good traction in that SimpliVity business, and in fact, we've been shipping now OmniStack on the HPE hardware for a few months. And more recently, now you can order it as a single SKU appliance, and we can deliver it from either our factory or our network of global channel partners around the world. Literally worldwide, we're now delivering the SimpliVity appliance as an HPE appliance. So really happy with that. With where that is, I would say the The results on that are exceeding our optimistic projections for what we thought we could do with SimpliVity. So we're really happy with the progress, and we have a rich roadmap coming up of things we're doing, including putting Gen 10 in there when Gen 10 comes out here in September. So whole lot of good action in the hyperconverged space, and I'll talk about in a little bit. Well, in fact, I'll mention a little bit about it now so that I don't forget. We bought SimpliVity not only for hyperconverged, but also because we love the data services so much, we thought it would fit really well in our composable infrastructure, so in our Synergy platforms. And we plan to bring that SimpliVity data, software-defined storage capability into our composable platform. So really looking forward to that. Second pillar is Synergy composable infrastructure. You guys have blogged about that in the past, and we've talked about it. And the best news on Synergy is that we've been shipping now since December in volume, and we have almost 400 customers globally around the world. People using it as to drive DevOps changes. We had people on stage here talking about that, as well as people using it as replacement for their Blade infrastructure. People using it to compose and recompose infrastructure dynamically to a set of workloads that span from bare metal workloads to virtualized workloads to container-based workloads, cloud-native workloads. So we're really pretty darn happy about that and the use cases. And in fact, we had a set of customers on stage. We had customers for SimpliVity as well. Forgot to mention that. In fact, Red Bull Racing was on stage with me yesterday. And then we've had a bunch of customers on stage with us on Synergy speaking about how they're using it. So some of the more notable ones, DreamWorks Animation, not only did my session, but had a main stage video some of you might have seen during Meg's presentation in the general session. So DreamWorks Animation, Redbox, Washington Department of Transportation, Symmetry, which is a service provider that's doing HANA in-memory database and Hadoop in the same Synergy frames and flexing resources to those two workloads and providing that as a service to their end customers. Who am I missing that we had on stage? I think I got at least the ones that were near my stage. I know there were some more that weren't on mine that we mentioned in some earlier sessions. So, and those, like I said, almost 400 customers worldwide. So Synergy has great traction. And it's obvious that it should, because there's nothing like it in the market that can do the things it can do. And what's amazing is even for customers who are just saying, hey, I just want to upgrade my traditional infrastructure. I'm not yet concerned about how I would use this to do anything beyond either virtual machines or bare metal. It has fantastic bandwidth and performance built for the next generation. We were shipping C7000 for 10 years, still are shipping, continuing on here. Synergy is built for the next 10 years and has fantastic performance and bandwidth. In fact, #1 VM benchmarks, #1 SAP benchmarks, a whole lot of things, and that's all on Gen 9. That's even before we ship Gen 10 with Synergy, which comes up here in September. So Synergy, great momentum. It's so fun to be here talking. I'm just beaming like a proud father when I see the videos of DreamWorks Animation talking about how, they're flexing workloads and doing rendering at night for animation and business processes during the day, and really taking advantage and exercising the full value proposition of what it was we were trying to deliver with Synergy, except now it's live and in production at these customers. So super excited about that.
Talk more about that, because that's a huge example.
Yeah, so here on the side, Chris is saying, hey, say a little more about that. Anything in particular?
So we talked about Synergy as being bimodal. And there was concern in the room when we talked about it last year about there's a lot of use cases where we're just saying replacement blades. And I think over this past year, I think we've all been really excited about how customers are using Synergy in a bimodal environment. And so those examples like DreamWorks and Symmetry, those are just perfect, because
It's really using the infrastructure the way we designed it.
Yeah, I think you just said it. Yeah, nicely done. So certainly we have customers using those use cases, and even customers. Hudson Alpha is now doing containers, and we had showed them in some of our, when we had beta customers, and they were talking about how they used it. So we didn't have them on stage this year because we've already had them do that several times. So an architecture that's built for the next generation here, that, if I had to summarize it, well, not only is it a great replacement for current traditional architectures, but it's the absolute ideal building block for private cloud solutions, no doubt about it. Built to be able to do that. And I would say the world's simplest on-premises infrastructure as a service engine that there is. Because infrastructure as a service is essentially built into the thing. You just ask for what storage, compute, and fabric you want to apply to workloads. And when you're done using those resources, they go back into a flexible pool. True infrastructure as a service, native in the box, ready to go, and customers are using that. So super happy about Synergy and the progress. And I would say, the thing I'm probably the most happy about. So I've worked at Hewlett Packard for 30 years. I was an R&D leader for a lot of those years. I've been running businesses now for almost 20 years. Have been on some of the most challenging products built from scratch inside HP in the history. And, when you introduce something that's brand new from the ground up, you'll oftentimes have some noise of, oh, there's this issue, that issue. It's just been fantastic quality since we came out with Synergy. And so we're super proud of that. Just essentially no issues that we're chasing in terms of either a bug that we just didn't see or anything like that. So it's just been extremely a positive experience for our customers. The other thing I will say is, dynamic provisioning is a really cool thing, but just quick instant provisioning of the infrastructure when it shows up is really huge. And I was telling somebody this story, which is really pretty cool. But it disappointed us at first. So when we started shipping the first volume Synergy systems, I wanted to make sure that those were landing okay, that people were able to get them installed. I wanted to know what their experience was. I wanted basically firsthand feedback from those customers. So we said, we'll establish a program where for the first 50 customers, we'll send out somebody with the units and kind of see how did the install go. And so we would ship the units out, we'd send the team out to help with install. And what happened on most of the early ones is our team would fly out, land, go to the customer site. The customer would say, we already unboxed, racked it, turned it on, it's self-installed. We're already running workloads on it. We don't really need your help or anything. So we got zero feedback on the earlier thing, which is, that seems like a small thing, but that's actually really huge. I mean, on prior generation blade systems and things like that, literally, it could be weeks for customers to get it racked, get everything set up, get the software installed, be ready to deploy a workload. But that stuff is preloaded. So that's what we mean when we talk about a software-defined value proposition that has to do with an integrated platform that shows up ready and fit for use. And then the third vector, and then I'll kind of pause for questions here, is around our hybrid IT management platform. And this is something we unveiled with a sneak preview and a tech preview and some NDA sessions, but we're also showing some high-level demos publicly, something we call HPE NewStack. And what it's about is delivering hybrid IT management in the most simple way possible. So with the work we've been doing in Hyperconverged and in Composable, and the work that we've been doing in my group on delivering Helion OpenStack installations and cloud system installations, we've learned a lot. We've learned a lot about what it takes to be simple. We've learned a lot about what it takes when you're trying to do ultimate in customizability. And what we learned from the Hyperconverged experience is customers are willing to pay for the simplicity of infrastructure showing up, ready to go, turn it on, answer a few questions, and it's rocking and rolling. Same thing I talked about with Synergy. What we learned from our Helion OpenStack installs is that a lot of those were big scale, and we still have many going on. But the amount of customization that we were allowing and the number of knobs of configuration that we're allowing and having our service engineers help customers install and put those in, that's really useful when you're a giant enterprise or a telco or some financial institutions where you really want your private cloud to look like a global public cloud. And you want it to be specifically tailored to your specific needs. A whole lot of customization. We call those snowflake cloud installations, meaning there's only one like it in the world, and they're very customized. But what we learned from that is that's not simple, and your mainstream enterprises, from small to large, really want to be able to do private cloud that applies to their traditional and their new estate, their new applications. And they want that delivered in a simple way, a lot like Hyperconverged. So if Hyperconverged is an old school private cloud, basically a VM farm done in the most simple way, what if you could do a new school private cloud in a super simple way? So private cloud that shows up, the appliance installs for itself, it's able to deploy traditional workloads and container-based workloads, and it's also ready to manage across a hybrid IT platform. So on-prem resources and off-prem resources into public cloud, the one of your choice. And so that's what the objective of what we meant to deliver with NewStack. And we're well down the road. We have beta customers signed up to be trying that out here in the fall. And we're driving aggressively to deliver that as an appliance-like experience with a unified control plane that it connects up to deliver on this simple hybrid IT vision. So it's bold, it's dramatic. If you think about it, it extends on our composable vision, because if with Synergy we're composing compute, storage, and fabric, now with NewStack we're composing workloads and applications across on and off-prem resources, so that you can build microservice-based applications that can have, you know, a back-end database that looks traditional, but a front-end, mobile front-end that is fit for tradition or new style cloud installation. So very powerful, very hybrid. You know, back to the mission: make hybrid IT simple. These three vectors are really helping us do that. So I can fill in some more details around some of that stuff, but maybe I've been speaking long enough. Why don't I pause, take a few questions, and I'm sure it'll spur some other thoughts. So yes, fire away. Microphone coming. Oh, and please, when you have your question, say your name and who you're with. So,
I'm Drew Conry Murray. I'm with Packet Pushers.
Yeah.
Could you help me understand how Composable is different from Hyperconverged? What the different value propositions are? And
yeah, sure. So, Hyperconverged is really, at this stage of the game, the state of the industry for Hyperconverged is to do that VM vending as quickly as possible. VM vending and VDI, those are the two primary use cases that are in Hyperconverged. And it does it really well, and it's a completely integrated vertical stack where the VM engine is embedded within. You have a user experience on top of that, but it's just straightforward. Give me a VM farm and give it to me at, you know, not giant data center scale, but at pretty reasonable size scale, so that I can do robo, back office, small data center, you know, that kind of thing. And I don't have to have an IT staff that knows a lot about either administrating VMs or anything. I just am able to run and deploy workloads on it. That's the core value proposition. And it's a wonderful product, and we're thrilled to have our offering in that spot. And welcome Paul Miller, my VP of Marketing, so he can help answer some of the questions. So that's kind of the hyperconverged space. Synergy adds to that kind of capability in a couple of ways. First, it ups the degree of hybrid, if you will, because it can deploy multiple workloads, not just VMs, right? It can do bare metal and flex resources against bare metal, which is very unique. You know, to this point, if customers wanted to dynamically have workloads use infrastructure, they really had to use techniques around virtualization to do that. Now we can apply dedicated chunks of bare metal infrastructure to a workload without a VM kind of as the in-between or the go-between. So bare metal plus VMs plus containers. It's built natively to be able to run containers, Docker capability pre-integrated, and now just as of Discover, Mesosphere as well, written to the Composable ecosystem API. So containers, and then of course we can support cloud native within those containers. So that it's kind of a lot more hybrid capable, but still focused on private on-prem, right? A Synergy is an on-prem capable device. And the other thing about Synergy is just the sheer scale. So where, typical hyperconverged installations are in the tens of nodes kind of configuration, a typical Synergy can be up in the hundreds of nodes. And even beyond that, but huge data center kind of scale. So a lot more scale, a lot more workload flexibility, a little bit less on the top end user experience. So rather than deploying or managing kind of the VM environment, Synergy doesn't manage all that, it just enables it. So think of it as infrastructure as a service across a variety of deployment models, super simple infrastructure as a service. So if you want something that kind of does more orchestration and management above that on a Synergy or frankly on a SimpliVity hyperconverged kind of thing, that's what NewStack is about, is more workload orchestration and management of the hybrid IT estate assets. So, where are workloads running? What's it costing me to run them in these different locations? As well as a secure developer environment is also a piece of NewStack. In fact, we'll go back and kind of summarize NewStack in a bit, but just trying to give you a feel for how these three things differ. Now, notice they all differ. We kind of see them almost as a nested picture. Maybe I don't have to. We kind of showed a slide in my, and now I'm afraid to draw on tape, but we'll. SimpliVity. Then we draw it like this. Synergy. Then we draw it like this, NewStack. And you have to kind of think a little bit 2D and a little bit 3D, but so this would be degree of hybrid, meaning how hybrid? Well, this is VMs only and on-prem only. This is VMs, containers, bare metal, and cloud native, but on-prem only. NewStack then adds kind of the capability of private and public. So that's that dimension. And then this is kind of capability and scale, where what's added here, or what's down here is scale is kind of tens of nodes typically. We do big ones, but generally people are there. VM, sorry, I should have put VM, container, bare metals, whatever, all that. Capability and scale on this axis. So this is kind of tens in terms of scale. This is hundreds to thousands of nodes in terms of scale. And then this is on and off prem, so it's a lot larger. But then also the capability, this is integrated run a VM. This is infrastructure as a service in a lot more flexible kind of way, and this is true hybrid IT stack deployment. So that's kind of visually how we've been representing it, but the three kind of fit hand in glove. What I mean by that is they're all consistent with this software-defined value proposition of it arrives fit for purpose, ready to use. There's not a big science fair project to get this stuff put together to actually use it to run workloads, which is what people are really trying to do. And so that's what it is. It's about make hybrid IT simple means embed software technology so that it automatically arrives and kind of does this model. And even when I describe the value proposition or what the user experience of a NewStack kind of device is, it's similar to hyperconverged, except it does a lot more. Ships as software embedded in the appliances. We'll put that on our Synergy and SimpliVity. That's why we have the box drawn around the outside. Shows up, you answer a few questions, and it basically says, oh, I know I'm part of a private cloud. I know that I have peers. I know that my cloud has containers and VMs. I'm now part of that, and I'm ready to accept workloads. And a unified control plane then deploys workloads against those pieces of capability, the units of infrastructure in there. So that's kind of the how they differ, but yet they differ, but they're all part of a family to achieve this simple vision.
So can I infer from the name of NewStack that this is HPE's sort of taking a run at OpenStack and rethinking it for the
I wouldn't
enterprise?
say it that way because actually OpenStack is one of the, we haven't figured out what to call them yet, but citizens within NewStack. So think of, it's not instead of, it's inclusive of, meaning if you can deploy VMs inside there of multiple flavors. Let's say, VMware VMs, KVM VVMs, Hyper-V. Those would be kind of citizens within the NewStack kind of thing, and we manage those deployments. And OpenStack is a really good citizen to kind of run a VM deployment kind of thing, right? It's built to basically do that. Where on some of the other parts, like some of the containers, tools like Kubernetes are pretty good to deploy containers and manage that. Tools like Docker, tools like Mesosphere. So those would be the citizens, if you will, inside NewStack that would do that. So NewStack isn't about writing custom code from scratch to compete with the OpenStacks, the Dockers, the Mesos. It's more writing integration software that pulls those things together in the way that a customer wants and gives an environment that's kind of managed under basically a CI/CD kind of environment that says, yep, those are citizens. They behave by these rules. We've constrained the configuration. It's not any OpenStack config. It's this specific one locked down this way. And you can deploy your applications against that. So think of it as almost a platform where those are citizens within that platform and they have a role within it. Hope that makes sense. Yeah. Oh, and just tap me if you feel like, hey, I want a piece of that question. Or we could hand you a mic too if you want to just bail in. That's probably easier.
Testing. There we go.
All right.
Okay. All right, Rick. Here we go. So, two fundamental questions. One is in regards to your comments about private cloud. So Azure Stack is planned on Gen 9, right? The classic Gen 9. When does Synergy come into the picture for Azure Stack?
So we're driving in that direction. It's going to be probably in 18. Our first implementation of Azure Stack will be a rack-based thing. I'm going to answer a question you didn't ask because in the context of what we were just talking about. So what does all this mean to Azure Stack? Think of Azure Stack as yet another citizen within that. Just like customers can buy, they can buy Docker on servers and deploy kind of a containers kind of thing. Azure Stack is its own on and off-prem kind of solution, but when you're in Azure Stack, the customers there know they're in Azure. So it has to be consistent with all, it has to be written for Azure, has to be kind of Hyper-V is the VM model there. That it's in the Azure Stack domain, where NewStack is trying to say, no, this is hybrid IT, not just one flavor of on and off-prem. Both are a good thing. If a customer wants just an Azure Stack on and off-prem solution, Azure Stack is great. If a customer wants a hybrid solution where they're running workloads in Azure, in AWS, in Google, and in on their on-prem infrastructure, then they need something that helps them kind of manage and orchestrate across those platforms. And that's more what NewStack is about.
Okay, so second question is around those 400 customers. So when we spoke last fall in Southern California, we were talking about the beta customers, and there was some confusion on how many of them were actually using the converged workloads.
Oh, yeah.
Right? I don't know if you recall the
I remember the question. I remember the question.
So of those 400 now, how many of those, so kind of two parts to this. One is, how many of those are service providers? How many of those are service providers versus enterprise customers? And the second piece is, how many of them are using it for that converged purpose as opposed to predominantly VM-based or predominantly the new style of applications?
So I'm gonna answer your question in a fuzzy way while Paul stalls and thinks about the exact numbers, because I don't have the exact numbers in my head. So that says I'm going to throw you in front of us.
I think we're about 30% service providers right now, maybe a little bit higher in the mix. But we have who's been on stage here with Symmetry is one on stage here. You have Scout 24, but or Muko, who's part of the Cloud 28 Plus. So there's a healthy 20 to 30%. I would say probably closer to 30% are service providers, and they range from large ones, rack space, and to smaller ones across the board.
Yeah,
And then
SAP, I mean,
Oh.
they're doing mixed.
Yeah, and they're all doing. A lot of them are. Most of them are doing standing up for mixed workloads. So all the service providers, like Symmetry, is running. They basically a SAP managed service, and so they run HANA, the SAP landscapes, and then a lot of HANA, will use Hadoop as a data lake. So they'll run all that on the same platform.
But that's a service provider, right?
Yeah.
So what about on the enterprise space? Are the majority of, so if I say 30% are service providers and 70% are enterprises. So of the 70%, how many of them are running the mixed workload approach? I get the service provider,
Yeah.
that makes sense.
Yeah.
But it kind of goes back to our conversation last fall where it seemed like that just hadn't clicked yet. And so I'm curious, has it clicked? And have you seen that in the 70% of the 400 that how many of them are running the mixed workload?
So I would say it's starting to click. And to
Okay.
reference customers here, DreamWorks Animation, right? They're using it to support multiple different animations movies. So it's still a rendering farm, but they're using it to support multiple different animator.
Well, and they're doing more than rendering
Yeah.
on it, right? They're flexing.
But that's that's kind of my point, right? Is I'm talking about VM versus the new style. That's what I mean when I say
and
mixed
then what
workload.
they're doing though, wait for the rest of the story. Wait, there's more, Tim. So, the way animation works is artists work all day, machines render at night. So in typical render farms, the infrastructure stays pretty stagnant during the day because there's not a lot of rendering going on. So what they're going to do is they're flexing in the day to use it for lines of business apps. So that's an example where they're doing mixed workloads from their targeted, rendering, which is their expertise, to doing lines of business during the day. So that's one that's there. I'd say most of the customers are entering on one workload, and now you're seeing them expand to multiple workloads. Because they're just starting to kick the tires, if you will. We're 5 months into shipping. So we're seeing them start with one, but then add on and start working on mixed workloads. I would say most of them have purchased it, though, because it's a mixed workload environment.
Or because they believe that they will need to do that at some point, because their mental model for what their on-prem estate is going to look like in the future is a lot more like a cloud. I mean, they want to flex resources against that. So there's a future-proofing kind of play for them. But what's interesting, this question comes up is, hey, well, if it's got all this new capability, is that the only place you would sell it? And the answer is, if you just take the thing and say, compare it to either our C7000 blade today, let's say you just want to use it as a traditional workload kind of thing, of either a VM farm or bare metal, and you just want to use it that way. Number one VM performance on the benchmark, and number one SAP, number one
spec JBB. So the number one on 2 and 4 socket, 2 and 4 socket vMark, right? It blows everyone away on vMark, which it surprised me because you'd think that pizza box or rack servers would be the top performing, but the architecture, the low latency of the backplane really shines performance. Spec JBB is kind of an all-around workload. They have multiple. We have number one on 6 of the Spec JBB benchmarks, and then the way SAP does it, you get in tiers, and we're in the top tier of the SAP. So, and these are all on Gen 9s. Gen 10 is coming. And frankly, we've got those 8 benchmarks because that's all the farther we've gotten. So the benchmarking is continuing.
And I'll chime in from there. So you would think, all right, you got leadership performance on just selling this as a traditional kind of infrastructure thing. Plus it's got this special sauce that allows you to do the kind of future private cloud kind of thing. Must cost a lot more. Answer to that is no, actually TCO of this versus any of our blade infrastructure today beats it across the board, except that the lowest one frame, it's a little bit more because you have a little extra capability from a composer and image streamer that can do more than one frame. But as you add 2 frames through N frames, it's 15% TCO better because our management technology can just, the management technology, the composer in that can run multiple frames. It's not built into every single frame. One plugged into one frame can manage for a whole bunch of others. So 15% TCO versus our own stuff. And then if you compare it to UCS, it destroys it across the board from a TCO point of view, from bottom to top, whether you're buying one frame or buying more. So for those customers, I mean, there's a strong value proposition to just say, upgrade your blades or rack to do virtualization or bare metal right now, and then you can use all the special sauce later if that's what you want to do. And a lot of our customers are doing exactly that too.
Another few more customers while I had some time to think. The Australian Academic Institute, I tried to get it right. They actually had, they looked across their portfolio of stuff they've rolled out over multiple years. 74 different types of systems, some with Sanitat, some with software defined, running all kinds of different elements. They did a floor sweep and now are running all those workloads on Synergy. And their workloads to support, students, their workloads support the research that they do. So there's some, compute farms in there. So they're really just said, I can't manage 74 different things and put them all together on one. One of the other customers you had on stage was the Washington Department of Transportation.
Yeah, I mentioned that before you got here. Yep.
Yeah.
Yep.
So they are also using mixed workloads. They're doing some of they provide a lot of mobile applications out to people to look at the traffic flow, to their operators of the ferries are all mobilely run apps, as well as they have kind of classic apps that just run, the operational side of their business. So that's another example of someone who's pushing mobile apps out to end users as well as employees, but then uses it for back-end operations to do scheduling and planning and whatever Department of Transportations do all day.
Okay.
Hey, Keith Townsend from the CTO Advisor and TechRepublic.com. So help us understand the roadmap a little bit and capability for NewStack, making hybrid IT simpler. The HPE has been talking about composable infrastructure, kind of this hybrid cloud IT journey for a couple of years now. From a customer base, I have to imagine there's huge business drivers for that. Customers have problems today that they need hybrid IT solutions for today. What are some of the leading demands for that you see that will be provided in either NewStack or the combination of Synergy, HCI, and all of the citizens of NewStack?
Yeah, so maybe I'll describe the kind of the state of the union in the customer, and then we'll talk about the specific kind of thing. So the state of the union in the, what should I say, the majority of enterprises today look something like their CEO asks CIO, do I have a private cloud? And the answer is yes. Regardless of this, that, but the answer is yes. But what they typically mean is they have a VM farm. They have, VMware, Hyper-V, or KVM running on a rack of servers, and they call that a private cloud. But that private cloud doesn't look like the public cloud, right? It doesn't have micro or service-based capabilities. It doesn't have infrastructure as a service. All of those kind of things. And then if you ask them, hey, is your environment hybrid? The answer is yes, because we have some developers that have logged on to the public cloud and they're doing some development there. And then we have the other stuff that we just described. But that really isn't what I would call the ideal state of hybrid IT. Hybrid IT would be where application developers can develop applications regardless of whether it's on-prem or off-prem. IT operations has pretty easy administration regardless of whether it's on or off-prem, where DevOps environment that's enabled so that devs can do most of the ops kind of capabilities. And so the third thing is so that the lines of business can have a view of their estate both on and off-prem. So that gives you the landscape. Where are the tension points? The tension points are, I'll give you an example. I have a Midwestern company that's got a pretty heavy software value proposition. I won't tell you what industry they're in because it would be pretty obvious who they are, but a big one. And every morning at 9 a.m., they have a review with their CFO of the company. This is, Fortune 100 big company. Review with the CFO of their public cloud spend. They're spending, an hour a week talking about public cloud spend. Why? Because developers have run out to the public cloud, have developed apps, now they're using them, and that cost has run rampantly out of control. And that's a huge concern for the company. So that's an example of a pain point use case that they're saying, wait a minute, most of my infrastructure that I have today on-prem is underutilized, yet I've got this huge public cloud bill because I've got developers that are quickly running out to get the latest tool and all that. And the reason is because there isn't an equivalent experience on-prem to be able to kind of do that quickly. So it's a key element of NewStack. It tells you why we have that kind of capability. Another pain point, lots of customer, and so that's kind of a NewStack specific one around developers. Now let me give you more of an IT ops kind of thing. The state of data centers, if you will, is very siloed still today, and most customers are still, I know that the words we talk about are further ahead, but most customers are still trying to get more virtualized as we speak. And in fact, for some of our data center infrastructure plays, half of that stuff goes out running bare metal applications and half runs virtualized, where you would think, well, most companies, aren't they 95% virtualized now? The answer is no, they're not. So, but those companies are under pressure, even for their traditional apps, to be able to make better use of the resources they have. And if they could do their provisioning across bare metal and virtualized workloads and take those silos and lump them together and be able to use that infrastructure together, much like Paul was saying about DreamWorks Animation, then they have to over provision a lot less, they get better resource utilization, and their costs go down. So, these are the tense situations. These are the conversations that I probably bump into at everywhere I go. If I show up and it's and what's interesting is visiting customers all the time used to show up would only be the CIO. Now often it's CIO plus line of business plus app developer lead, and they're having a conversation about, hey, can we use some of our infrastructure that we're buying to run the business to also do app development? And the answer up to this point was not super easily. We got to solve that problem. Can I get a view of the expense across this so that the three of us, IT ops, line of business, and developer, can know where we're spending? Today, not very easily. You can get kind of a bill from the public cloud, but you can't really tell because it's CapEx kind of thing. Can I pay on a consumption basis? The answer today in on-prem, we can do it in our flex capacity. Most vendors can't do it very well at all. So bringing all those things together and saying, look, this is an estate of capability, and it's got to be managed in a cloud-like manner, in a simple manner, regardless of whether or not it's for cloud-native applications. The expectation has risen that even traditional infrastructure running traditional applications has to be shareable, has to be service-oriented, has to be DevOps, where I don't need a giant staff of people to do upgrades for firmware and all that. So the work that we're doing to make hybrid IT simple makes traditional IT a heck of a lot simpler as well. And that resonates like crazy with our customers. So those are probably a few of the key pain points that we're solving and that are part of the conversations we have every day.
Sorry, it jumped off again. Sorry. Just a quick clarifying question on that. So do your conversations with those companies get to the next layer of detail? Because what I see is that when you take those enterprise applications, and my perspective is that the applications move to public cloud, but they're not optimized for public cloud. And that's ultimately what drives the cost way up. And I've done a number of studies and metrics around this. And so then they want to come back. I mean, arguably HPE has a vested interest in wanting those workloads back because you sell more infrastructure, right? It's not optimized code. So of course, I get that. But what I'm curious about is if you get into the next layer of detail around how to optimize those applications so that the resources are used more effectively, not just, hey, you're using this much on public cloud, you're using this much locally. Does that make sense?
It makes sense. So, okay. In solving a problem, sometimes the first step is awareness. So think of it that way. Step one in New Stack is awareness. Where am I spending my money? That'll help me kind of be able to say, oh, you know, didn't realize I've got this much going here, and it's easy. By the way, this Monday 9 a.m. thing isn't that easy, particularly when they try to say, well, is that a lot? I don't know. Let's compare it to my internal. Well, I can't tell you what the internal is because we paid by CapEx, and right. So providing that is a big step. So there's an awareness thing. But what's interesting to me, and this, you know, I will remember this moment, is you said something that we haven't heard in these meetings, which is a definite new thing in the industry, and you even brought it up, which is people are coming back. That conversation 2 years ago was like, no one will ever come back. Everything's going to the public cloud. It's just a matter of time, and it'll always be there. The conversations I'm having with customers now, and believe me, there is a place for public cloud, and it will continue to grow. I'll be the first to kind of say that. But I think the difference in the conversation was 2 to 3 years ago, people were saying that's the end destination and it's a matter of time. Where now they're saying, no, it's hybrid IT. I'm going to have some stuff on, some stuff off. There'll be companies that have differing degrees of how much they want to be in either. But many companies aren't going to go through the effort of trying to optimize and, you know, get a application kind of done a different way in a public cloud, particularly if they can do it in a cloud-like fashion, a bare metal application, don't have to rewrite, don't have to mess around, but I can get better utilization, better performance in the environment that I'm in today. Why go through a bunch of effort to move it? So that whole rebound, boomerang, you know, there's this whole thing going on that's actually pretty new in the industry, and that is people are going, oh, I'm locked in. This costs a lot. That doesn't look quite exactly like I imagined it to be. Now,
arguably, it's been going on. It's just that nobody's been talking
about it. Exactly. I agree with you. But the fact that in a blogger session where we're talking about that kind of stuff, it comes up. It wasn't coming up, so I think it's awesome. Richard.
Yeah, thanks. Richard Buckle, Pilot Technologies. I may be older than some, but you talk about the pendulum. And I had to sit through where I had to get off my mainframe because I was going time sharing. And I got a little terminal, and everyone said the mainframe's dead, 1969. Well, we've seen a lot of this before. Synergy mixed workloads. Do you see the virtualized nonstop as being one of the workloads hosted on Synergy?
Yes, I do see that. I don't know if we've done it yet. I don't think so. But I think, you know, I've been talking with my old friends, Randy Meyer and crew there, and now that they're fully driving in virtualization and containerization, you know, I don't see a reason why not.
No, I saw from that picture.
Yeah.
I don't think
we haven't announced it as a roadmap thing, but I don't see a technical reason why we wouldn't do that. We just maybe haven't talked about it yet. Randy's playing with it. Randy's going to be mad because now we've publicly said he's playing with it. So.
Okay, I couldn't see any barriers to not yet.
No, I don't see a reason why not.
And would that, and would that help, and I hate to say this in this community here, but would that help bring nonstop even closer into HPE? If I can use that kind of expression?
Well, you know, as a former leader of Nonstop at one point in my career, I think Nonstop is in HPE, as rich as it possibly. So I don't know if it can be closer or more in than it is. It's a hugely successful value proposition that is cherished by HPE. There's no doubt about that. I mean, and a very strong business and continues to modernize, running on x86 now, you know, and running, you know, KVM, you know, so it's a strong value proposition. No issues there. It is a rich part of HPE. Okay, there's another one over here.
So it seems like a lot of great hero numbers around SAP, and I'm assuming that's SAP on Oracle. Synergy seems like the perfect platform for SAP HANA and other in-memory database solutions. Where's Synergy and certification for SAP HANA?
So the benchmarks, we're actually using HANA, and where we do have support for HANA now full. So you can configure HANA with this. We use the TDI approach, and customers can build images and deploy HANA in scale out or scale up. I think our 4-socket today has, how many terabytes of memory? Yeah, I don't remember. But we can do small, medium type HANA, right? It's not as big as what the Superdome X does, that can scale to 16 plus terabytes of in-memory data. I think we're in the I think we're in the 4 to 8 range for scale up. But then it's an excellent platform for scale out HANA. So we're just starting to push that out to the marketplace. We got certification roughly 45 days ago from SAP.
So that's great news. And then the other piece of it is, since you mentioned Superdome and the Synergy and Composable platform, early question, Superdome, after hearing the hero numbers yesterday about the machine and what's capable, it seems like the perfect platform for Composable, new stack, Synergy in general. Where's Superdome? Where's the roadmap in integrating Superdome X into this this composable architecture?
I thought you were going to ask about the machine, so I was thinking about the different thing. So Superdome X, I believe we've announced OneView support for Superdome X. Yeah, if we didn't, we just did.
No, we did, yeah.
So that's one way to think of it. So a little bit like OneView runs on our current Blade system, but the current Blade system can't do quite all the magic of flexing resources because there were hardware dependencies in there that we kind of fixed when we did Synergy to make it so that all of that is seamless and you can plug anything anywhere and have it work, regardless of, we want to put all storage in this one and all compute in another one, fine. You want to mix it up, doesn't matter where you plug things, it's just infrastructure from the point of view of Synergy. Similarly, Superdome, you can manage it like a composable infrastructure, but it isn't built with all that flexibility in the chassis. And then I'm going to answer the question you didn't ask, but I thought you were headed to, because you said we saw the hero things on the machine. Those machine technologies like photonics and some of the memory-centric computing, to me, those are big time about disaggregation of resources, because things can be physically further apart and yet still appear close together with photonics, because you got super bandwidth and that kind of capability, giant persistent memory. All of those fit really well with the composable architecture. If you think about it, if resources can be disaggregated and put far apart, but yet dynamically composed, if you will, to run against a workload. So that is definitely part of our vision of where Synergy goes. Is right now we do disaggregation at the chassis kind of level, compute storage fabric within a set of chassis. But imagine that if you could do that across a data center or even outside a data center. The storage for this job lives across town, but we compose the storage for a given workload across geographical boundaries. Synergy's plumbed for photonics, because we believe that infrastructure, 10-year life of that infrastructure has got to be ready to go. So we've architected it to be ready to do exactly that. So it's just one example of the machine technologies working their way into the composable value proposition. All right, next.
For the new stack, it sounds like it's going to be the orchestrator for hybrid IT. As a business, how do you balance the fact that that's a good product that customers want to use versus making it just too easy to on-ramp onto the cloud?
You have to be confident that the economics of both on-prem and off-prem are going to be in the same range, and we're really confident because we can look right now today. You can go out and download a study done by Cloud Genera, who they basically do this as their business model, is do cloud assessments and see how we're delivering today VMs in a Synergy on-prem chassis for half the cost of what it'll cost you on Amazon. So if we didn't think we could compete from a experience and economics point of view, you might have something there where you're going, hey, aren't you making it easier for an on-ramp? Our mental model is there's no such thing as an on-ramp. Public cloud is a tool of infrastructure, just like private cloud is a tool of infrastructure, just like mission critical is a tool of infrastructure, just like, it's just another flavor of infrastructure. And over time, the difference between on and off-prem will get less and less relevant as the experience and the consumption model paying and all of that become more equivalent. then it's just an economic decision, and we want to empower customers to play off whatever their best economic situation is. You know, our general advice to people who are embracing the cloud is that's absolutely a good thing, no problem with that. Just do it in a smart way, meaning focus on container-based deployment of your applications, because we believe in the future you're going to want to move those around. Don't focus on deep API, locked in, walled garden, siloed, you know, mainframe of the future type implementation to one particular public cloud in particular, because you'll be locked in, and that's probably not such a good thing for you. But absolutely, if you're developing in a way that is cloud agnostic, I think it's a great piece of technology, as on-prem will be as well in the future.
So let me answer that a little bit different way, right? I believe that there's going to be more clouds, right? The managed cloud is one of the fastest growing clouds out there, and our Cloud 28 partnerships and community, if you're not familiar with them.
That's a good point too.
They are very excited about New Stack. We actually pre-briefed some about 2 months ago, and they are now, you know, one of the big advocates. Because what we see is, and this is even with talking to Microsoft, right? Microsoft loves Azure Stack on premise because they know, and the service providers are adopting it really, really fast. We announced, I think, 7 or 8 of them are on HP. You know, it's not launched yet, officially launches second half available. But because the importance of having managed services as part of your cloud mix. And we think we're going to do the right things and have, you know, on Synergy, on SimpliVity, the biggest portion of managed services running on HP gear. So as more of these multiple clouds come up, you know, you kind of got, and you know, the big cloud providers, but the managed cloud one we think is going to be great. And then this platform of New Stack helps you manage across all that. So partners, yeah, I actually had a channel partner say, he had a similar type question, but then he started thinking about it and he says, oh man, now I'm part of your catalog here, and this will help me grow my business as well. Make sense?
So maybe then this question is slightly related. I'm thinking about what you said about New Stack and citizens and this whole sort of nested doll structure. So if Kubernetes and Mesos are citizens in New Stack, are you anticipating that different audiences are going to use different layers? Like some developers will use Kubernetes, some will use Mesos, and then there'll be a sort of a manager layer who's looking at New Stack, or do you also anticipate developers are going to use New Stack as an orchestration platform?
I'm not sure I completely grokked that. I was with you, right? So do you mean when we have an API coming out the top where people call New Stack? Is that your question?
Yeah.
Possibly. I mean, our general mental model is New Stack is the environment, the landscape, if you will, and there are pieces that plug into that, and that those are flexible kind of choices. And I mentioned, you know, the ones that are there. I have one more story for you that's kind of related, but it kind of goes back to this app developer thing. I mentioned how I'm showing up more and more and seeing line of business, app dev lead, and IT operations guy in the customer meetings. We had one customer yesterday here that said they brought out their app dev guy and their infrastructure guy and in fact server infrastructure guy to check out Synergy on the show floor. And because they're having this internal battle about, you know, hey, cloud, what does that mean? Does cloud necessarily mean off-prem, or does it just mean on-prem? Those kind of things. And so the guy took the two to the Synergy area, and then he came back to talk to him, and he said to the server infrastructure guy, hey, what'd you think of Synergy? And the developer guy jumped in and said, it was fantastic. I really want to use that for my app development. So that's kind of one of those stories where it's like, that's exactly what we're trying to do. That is not say, hey, you don't need a public cloud, but say, hey, you know, these are implementation options, and they can be a lot more closely related than they seem and are currently today. So it just kind of tells you where we're at in this journey and making a ton of progress every day. So I think we're out of time. I want to make sure I at least say a few things and wrap or whatever. 3 minutes. Does it take me 3 minutes? We can do one more question and then we'll do a close.
So combined question from me and Tim, which is on I think jumping off of your question, Drew, which is entry point into the hybrid IT cloud and where HPE plays a role in that. Today, shadow IT is driven by the developer. That AWS kind of owns that relationship. Seems like there's a need for HPE to also own not only the infrastructure relationship, but the relationship with the developer. Do you see that as a role of HPE with NewStack, or do you rely on your infrastructure company partners inside of the organization to kind of build and champion NewStack?
Yeah, so I have a deeper answer to that. You know, I mentioned there are 3 key areas of development for NewStack. First, there's that how you deploy workloads and orchestrate and manage. The second was around the metering and analytics for the line of business. The third was around the developer and making sure that they have an on-prem experience that allows them to develop. And, you know, I'll just address kind of the elephant that often comes up is, well, how can you possibly curate a development environment that keeps up with the public cloud? Because there's new tools and services and microservices going out there every day. And what we found in talking to the enterprises is, much like, you know, you have a phone, Android or iOS, whatever, and there's 1 million applications that you could download on that phone. But if we went around this room and said, how many do we have downloaded on our phone, the sum total of that, it's probably 100 or 2, or, you know, it's something, you know, we don't have 1 million applications on our phone, even though they're available. I think that same is getting to be true in microservice developer kind of services, and that is there's a core set of them, and if you can enable those, then you can do most of the development. And hey, if they're not in that core set, then fine, go to where you need to get them to do that development of that specific microservice. But if you can orchestrate across where the microservices live, they don't all have to live together. Some can live in the public, some can live in private. Then you kind of have most of the use cases covered. So back to answering your question, we know we have to be relevant to the developers to make that on-prem experience similar, but we don't have to solve world hunger to be relevant to the developers. We just have to hit kind of the majority of the use cases. And the thing that we can do that's pretty cool is this way, for the on-prem stuff, the IT ops guys can be in control of which of those services the developers get to use a little bit, so that they can verify that these are microservices that are going to be secure, safe, that won't mess up stuff that's going on the rest of the enterprise. And that's a really strong value proposition in that context. So and that way the whole organization is happy, rather than kind of, you said, shadow IT kind of going on. If everybody's on board and you can get the same experience and you have what you need, then, you know, there doesn't need to be a whole bunch of shadow IT going on. So anyway, other thoughts on that one?
No, I think you hit it.
Okay. So anyway, want to thank you guys a lot. These sessions are always entertaining, and we kind of get a good pulse for, you know, what are the hot topics going on. So it's useful for us. I hope it's useful for you, and we'll look forward to doing this again soon. Thank you very much.
That's kind of some of the concepts that I'm trying out here. I'm asking these customers, what do you think? Yeah, I got it.
Gonna get going.
I'm going to go. We're going to get going.
We're going to get started, so you have to stop the side conversation. Hey, we're back again. This is the Coffee Talks here at HPE Discover. And now we're going to have a look at this new generation of compute experience brought to us by HPE. And we have Bob and we have Brett. And I'll just hand over to you guys to get started.
Well, thanks. Yeah, we're really excited about this. This is fabulous. We're introducing. I've been with HP Compact for many years. As you can tell, I'm looking quite worn out these days. But we're really excited about this. I think this is one of the more exciting announcements we've had probably in a decade. We probably not have anything this exciting in quite a long time. So, yeah, we're thrilled about it. And it, of course, we are basing the new innovations, or they're fitting into a triumvirate of three basic pillars of enablement, and that's agility, security, and economic control, of course. And so we have, by bringing these things together, and the nice thing is, of course, we're not going to go into any of the details of what's inside the processor or anything, because that announcement hasn't been made yet on what the speeds and feeds are of the processor. So we're just covering the HPE technology, and it's really quite amazing, I think, you'll find, with all of the great stuff that we've innovated on with our three pillars: agility, security, and economic control. With agility, we've got the new scalable persistent memory that Brett will talk to. That's exciting stuff. We also have intelligent system tuning that's part of that, and that's these things are new and exclusive to HPE. Only HPE has these, so it really helps differentiate us, and that's why I think it's so exciting. And then the security pillar is, of course, new revolutionary security technology that also is differentiated for HPE. And then finally, the economic control brings to light some of the new HPE Pointnext services that provide a great alternative to a public cloud environment, helping customers not get locked in. So if you don't mind, we'll take those one at a time and maybe talk about agility first. And Brett, you can cover that with persistent memory, and then I'll add into that intelligent system tuning that make up and round out that pillar.
Okay, thank you, Bob. Thanks for that introduction. I'm Brett Gibbs. I'm the Persistent Memory Product Manager. And as Bob mentioned, in the agility pillar, we have many things going on. I'm the Persistent Memory Product Manager, so I'm going to talk to you a little bit about what we just announced here at Discover in Vegas. We announced a new HPE Scalable Persistent Memory. Okay, what is scalable persistent memory? Let's kind of start with a little background on this product category. Persistent memory is the product category name describing products that run on the memory bus, but are used for storage use cases. So in Gen 9, we launched our first product in that category, the 8 gig NVDIMM. And the NVDIMM is essentially a DIMM backed by flash, runs on the memory bus, but is actually used for small storage bottlenecks, right? Things like, the transaction logs in database, caching tiers, things like that. So what's new in Gen 10 is, with this new scalable persistent memory, we're now taking it to the next level. What we have now is a terabyte scale persistent memory running at DRAM speeds. And what this is going to unlock is new levels, not only new levels of performance, but new use cases. Running in memory is nothing new. That's what applications have done forever. Running in memory with persistence, so your data in flight running in memory has a persistent layer, is what is new, right? And so the way we accomplish this, the NVDIMM is a new hardware product that we throw on the memory bus, right? So whenever you throw new technology on a memory bus, there's a lot of underlying things that have to change: the memory reference code, the BIOS optimization, and so forth. We said, hey, what if we took existing memory, HPE Smart Memory, and through BIOS means we tell that portion of memory, you're going to report back to me as scalable persistent memory, and we can do up to a terabyte, and it's flexible in how you configure it as well. DRAM is used for application acceleration. We use a tier of flash that's dedicated as a backup for that DRAM. So in the event that power comes down, whether it's through a surprise power loss or a graceful shutdown, that data moves from DRAM to your flash tier. And again, that flash tier is a dedicated flash tier. And you have to have a backup power source. So we have a new power supply that has a embedded battery backup capability. That facilitates the movement of data from DRAM to the flash tier. Okay, I've kind of told you what it is. What does it do for customers, right? That's really the important thing. Larger in-memory compute with persistence. That's one. Think about a Microsoft SQL Server Hekaton in-memory database and the ability to run that data in flight. Again, running in memory is not new, but running in memory with persistence is. And so typically what you do in any kind of application is anything running in memory occasionally does a checkpoint. Okay, a checkpoint is simply a save off to non-volatile media. That is an area of latency or a storage bottleneck that many customers that face. And we actually have some demos that kind of demonstrate how the impact of checkpointing using hard drives versus SSDs versus scalable persistent memory. I like to call it a bad EKG, because if you look at it, whenever we checkpoint to slower block storage, you tend to see drops in application performance. So every time that checkpoint happens, you'll see that drop in performance. SSD improves, definitely, because you're writing to a flash tier. But when you get all the way to the scalable persistent memory, what you see is more predictable performance. So instead of those drops during the checkpoint, you start seeing things smooth out. Also with Hekaton, we did an experiment where we took a 200 gig Hekaton in-memory database running about 500,000 transactions per second. So you got quite a few things going on there. We took it down, and with a layer of SAS SSDs, we did a restart, and essentially that pulls the data back from block storage and puts it onto a layer of SAS SSDs. We were back up and running in a very respectable 20 minutes. We repeated the test, we took it down, and then I put it into scalable persistent memory. The database restart time went from 20 minutes to 45 seconds. So the enabler here is you're using DRAM on the memory bus, low nanoseconds of latency relative to PCIe, which is measured typically in the microseconds of latency, and enables quite a few new use cases. So that in a nutshell is scalable persistent memory. We're also continuing our NVDIMMs. NVDIMMs are good for smaller storage bottlenecks. And the idea is, I like to say they're right-sized capacity. So some of the use cases that we focus on are in the low gigabytes. The best problem solver for that is low capacity NVDIMM technology using DRAM backed by flash to get that memory-like performance, but get the persistence of storage. So that's it.
So Brett, if I'm buying this as I need a server that's got the scalable persistent memory, how does that look different as a purchase? Am I buying a particular SKU of server? Is it just that I need to buy a different SKU of power supply and then make sure I have that tier? What does it actually look like?
Right. Great question. Market enablement. This is something we spent quite a bit of time studying. It's one thing to make a nice product out there and throw it out in the market. It's another one to put a solution together. But if we do not make this easy for our customers to buy and for our channel partners to sell, we won't be successful. I don't care if it prints gold bars. It's not. We got to make it where it's easy to purchase. So initially, the way we have envisioned coming out in the market with this, we're going to make this available through our HPE factory configuration orders. We have SKUs that we call trigger SKUs. Essentially, when you purchase these, they provide the appropriate memory, the appropriate flash tier, and the battery backup source, as well as the infrastructure. But we also don't want to do an appliance where we lock you into a specific processor. So, for example, on the DL380, you'll be able to choose the other supported options. So we give you the flexibility of giving you everything you need with these trigger SKUs, while also preserving that capability to choose the other supported options on that platform. That's the initial phase. Phase two, we're looking at working through our channel partner community to help enable them in the market. I can provide them a menu on how to put this together. There's a lot of smart individuals out there, so what if we allowed them to be able to configure these directly for our customers? So we're looking at doing kind of a more build-your-own model down the road.
And then the other angle on this is we heard about the machine and the machine architecture yesterday. We discussed it a little more this morning. There's a lot of similarities in what you're achieving, but it's clearly going to be about different sets of applications, and this is something that we can buy in the next few months rather than in a few years' time. Can you sort of frame how the two ways of using persistent DRAM are different for customers?
Okay, excellent question. I think one of the key points we want to make is we outline a great vision of the machine and memory-driven computing, the architecture for the machine, and this kind of this vision of a shared pool of memory that can be used. What we're talking about, NVDIMMs are shipping today in Gen 9, and our next generation will be shipping with our Gen 10 product, as well as this new scalable persistent memory. The analogy I like to use is the Apollo program, the Apollo space program in the U.S., where Apollo 11 landed on the moon, right? In order to get Apollo 11 on the moon, you had to have missions 1 through 10. 1 through 10 didn't happen. We weren't landing 11 on the moon. With my 8 gig NVDIMM, that was the Apollo 1 mission. I have the Apollo 2 mission with my new 16 gig.
Please, the 8 gig DIMM is Apollo 2. Apollo 1, they all died.
Well, yeah, well, that's perhaps not that, but we're going to give them homage. Those were brave souls, right? You gotta step out there and be the first. But that analogy, really what I'm going with is the fact that this is what we're shipping and is available today to customers. And to get to that real vision of memory-driven computing utopia, it's going to take steps along that journey to get there. And so with this persistent memory, it's fulfilling the long-term vision of memory-driven computing. So that's the tie-in. Real product today to help fulfill the vision of memory-driven computing in the future.
So on more of a practical side for that scalable non-volatile memory, are the form factors not changing from what we have today in the 8 and the 16 gig when we scale up to the 1 terabyte per? And how does the changes to the architecture of it affect the thermal and other operational characteristics of a server that's loaded chock full of this stuff?
Okay, great question. So the NVDIMMs are both hardware and software ecosystem. But it's unique hardware, right? I'm actually putting something new on the memory bus, a DIMM backed by flash, which differs from the traditional RDIMM that you use for server memory. With scalable persistent memory, I'm actually leveraging the memory that is actually on the memory bus, the HPE Smart Memory. I'm leveraging flash that's used in the data center today. Now, the power supply that I'm talking about is in a flex slot form factor. What's new, what's unique is having lithium ion contained within that flex slot power supply. We've made a design in the DL380, an air baffle that helps bring keep the ambient temperature lower for that power supply, because as you know, you want to keep ambient temperature exposure down whenever you're using lithium ion. Thermals are not an issue because we're leveraging the existing memory, we're leveraging flash, and so that's the cool thing about this. We're not going to ask our customers to go put necessarily new widgets in the box with a scalable persistent memory. Why not use the DRAM and the flash and the backup power that you've traditionally used in your server for this new solution? So
does that mean that the flash is going to be put in the front end just like any of the other SSDs, but dedicated in the setup of the server? So you go into the boot configuration piece and say, this is the SSD that I'm going to dedicate over to the scalable, or how operationally do we look at this?
Operationally, so we're actually using 2.5-inch NVMe drives in our initial implementation. The cool thing about this design is that I can, as I move into different phases, I can look at using different things. But our initial release, we wanted to have the highest bandwidth flash available in the server, and that's the NVMe drives. So those 2.5-inch NVMe drives will go in the normal drive bays that you see in the ProLiant server. They will be dedicated. They actually will not present back to the operating system as available storage. We dedicate it specifically to scalable persistent memory. All the configuration rules, how much persistent memory you allocate is controlled. There are some BIOS settings, and we use the ILO REST interface so customers can go in there, and if they need to change the persistent memory regional size, they're able to do so. Kind of hence the scalable name, which allows you to, if you want to back some of that off and allocate some of that memory back to server memory, you can do that. If you want to increase it and you want to increase the memory size, you add additional memory, and you should be able to, go in there into the settings and change the persistent memory region size.
So is that going to be an obviously labeled slot in the front panel for where you're putting the 2.5 inch in, or when we talk about dedicating, is that because the tracings are different, not just because it's NVMe, but because of the way that it's going to have to be able to have fast route to destage all those pieces, or is it?
Yeah, great question. How are customers going to know? So our initial market implementation of this, we're going to do HPE factory configuration. So the only way you'll be able to purchase this is through the factory configuration where you purchase these SKUs. And in the factory, we not only include the appropriate memory, flash, and backup power and related infrastructure, we actually do the installation for you. We have a factory script that runs that performs the appropriate BIOS settings for setting the scalable persistent memory region. The vision here is that when it leaves the HPE factory and final config is done, that it lands in the data center and is ready to be run as a scalable persistent memory region for the storage workloads.
Last question. Is there any option for doing PCIe for the NVMe instead of using up valuable drive slots?
Initially, no, but one of the things I want to kind of signal to you guys today is, our initial release is going to be somewhat fixed as far as the flash tier, but we are looking at ways to do things differently. So maybe perhaps looking at flash inside the server instead of a drive bay, number one. Also looking at more cost-effective ways to bring what I call the cost of persistence down. Cost of persistence, of course, is your flash tier and your backup power. So phase 2, one of the areas that we're investigating is potentially looking at going outside the box and tapping into UPS power inside the rack, right? Many enterprise customers already have this problem solved, right? It's not a unique problem that we're trying to solve in persistent memory land. The problem of unplanned downtime due to power loss, enterprises have already mitigated against that. So we're looking at kind of unique ways to solve this problem, bring the price point down, and also increase the flexibility of how you configure this.
Just a small tip, relying on the UPS doesn't help the human factor, because the number of times that I pulled the wrong cable, or worse yet, somebody else has, here's the right cable, you pull it, and it turns out that was the wrong one, even though you thought you traced it. You definitely want those batteries inside the chassis.
Yeah, so great point, and that's we realize that as a product manager, when I'm looking at this, I realize that complete solution in the box will be a product that will continue. We're looking at other ways to get this on additional platforms and more market reach. But you're right, we have the human factor. We always have to build in that design, right? Thank you.
And Brett, one more from me, again around the operational piece. The destaging from RAM out to the flash and the restaging on boot is all in BIOS. Does that mean this is a different BIOS to the standard BIOS for the model of server that we implement this on?
Great question. This is not unique BIOS, except that it's unique to HPE, right? That's one of the other things that when we were looking at market enablement, we looked at the traditional ways of how do we license this? And we decided that that's not what the path we wanted to take, right? We want to make this as easy as possible for our customers to enable. So again, the idea is for initial enablement, let's go do these factory config SKUs, let's drop it in the data center ready to run. But again, I think pretty quickly we're going to look and see how can we allow customers to kind of build their own solution. We just want to make sure that we have all the required components out there so it's ready to run day one.
Okay, great. That was super. Man, you are quite the subject matter expert. That's super. Okay, so let me continue now. Now we've covered the first part of the agility pillar, right? So we have agility, security, economic control, and I'm going to add to that a little bit to the agility pillar, and that's with a new technology that's very new, unique, differentiated for HPE, and that's intelligent system tuning that we've announced this week. So intelligent system tuning it has three components, and I'll go through each of those three briefly, and then you can ask questions about that. The first one is jitter smoothing, is what we're calling it, and that is particularly important for the FSI vertical market segment. Heretofore, those FSI, especially if you're doing high-frequency trading, you've typically not been able to invoke the turbo mode because it creates a little bit of jitter, or that sinusoidal wave function that you get when you jump up. And so every time then you turn from going down in frequency to back up, the processor's actually looking where it's going to land next, and it's not doing trading at that time. So what we do is we're actually working a little bit with Intel, and we're getting the information that we need from the processor to then dampen that out, so we can actually deliver deterministic frequency at higher than baseline. So the FSIs, the high frequency traders, can invoke or go up into turbo mode and have completely flat deterministic frequency, which is really remarkably important for them, just incredibly important. Before this, they would just buy the highest processor that they could with the most performance, and then not go into turbo mode. Now we can do that for them and provide that higher level. And the benchmark, the internal lab results that we've got indicates is about 12% higher than what the baseline frequency would be, up to 12%. So it's pretty significant. We add to that, that's jitter smoothing. And really great for the FSI as well as a couple of other markets like video streaming. The second thing we've done, and this has really been in collaboration with Intel, is our core boosting technology. What we've done is worked with Intel on a few private SKUs, an 8, 16, 24 core a private offering that's not on their roadmap, that's just unique and privately offered to HPE, and then we'll offer these in our Gen 10 servers. We are actually able to boost up or increase the thermal design point while keeping the cooling, thanks to our IP cooling stuff that we've got inside the server, the technology that we've got inside the server. We can actually increase the performance and, most importantly, keep more cores on active as we go up into the turbo mode. So when you normally, with the Intel turbo mode, you would be shedding cores in almost a linear fashion, we can now keep up to 33% more on and in the active mode as we boost up into frequency. So this is important. Why? Well, it provides more cores at a higher frequency. Naturally, that's certainly a plus, but it also conversely offers fewer cores at the same frequency. So if you're concerned with the licensing, application licensing expense, we can reduce the core count that those customers have at a set frequency. So that's fairly significant. And then we can go the other direction. We can come down for non-peak period when we don't have a lot of load or demand on the workload. We can come down and save that energy for obviously cost savings and energy efficiency. So that's the second one, that's core boosting. And then the third component of this great new and only HPE technology is our workload matching. So normally, of course, in the BIOS, you have a number of different settings that you can adjust and tweak and spend a lot of time getting exactly accurate. What we've done is created 15 predetermined workload settings that you invoke through ILO, and then those will be pre-optimized for a workload that you may choose to run. So let's say you're running a virtualized workload. You simply click on that virtualized workload in ILO, and then that tunes all those knobs to be the most optimum configuration of the server to meet the needs of that workload. So those are the three things, and of course we have some telemetry that monitors all of that along the way. That's intelligent system tuning. Any questions on that?
In your 15 choices, you mentioned virtualization as an example. Those of us that work in virtualization day in and day out know that you could use all 15 with various virtualization workloads. Is there going to be a custom to let us override everything and tune it ourselves for the places where we know we need to?
Yeah, I'm glad you asked that, because at HPE, we're all about customer choice, as you've heard our senior leadership talk about. So naturally, you can still do that. What we're trying to do is, and we actually have a couple of virtualized workload environments as part of that 15. So we know that's a big demand. So several of those are just for virtualized environments or virtualized workloads. But should the customer still want to go back and make all those fine-tune adjustments, they certainly are free to be able to do that. We just want to save time, money, energy, and effort if we can.
To follow on to that, hypervisors have sometimes been challenged. Sometimes, I think they're currently all challenged by some of the dynamic loading, unloading in the servers. Kind of the best practice has always been set it for maximum performance and walk away. In this new environment, are we also going to have some custom drivers that will actually bring some intelligence into those hypervisors that are really stupid about power tapping and some of those pieces that cause us today to just full performance and walk away?
Well, we'd like to be able to do as much of that as we can. I'm not sure that we can solve every single problem in that particular case. Or you might call it, yeah, it sounds like you're trying to make it idiot-proof or something like that. I wouldn't go that far, nor would I call our customers idiots for sure. But we're trying to make sure that we're maximizing the ability to performance tune.
To be clear, I'm talking about the hypervisors being idiots,
Very good.
not the users of the hypervisors.
Thank you very much. That's a good distinction. Yes?
So what's the process for adding to those 15 predetermined workloads? Do you have a lab? How do you do testing? How do you select the applications?
So what we've done is predetermine them based on talking, a lot of conversations with customers on what we think are the most utilized workloads, I think is what you're asking. How did we pick those, and can we add more? Well, the answer is right now they're predetermined at those 15 states. We probably will look at adding more in the future. Going out the door with the shipment of Gen 10, it'll be those 15 that are pre-selected. Always talking to customers though, and always willing to make adjustments as we always would down the road. Let me shift and talk about security then a little bit if I could. That's the second pillar. So we did agility, now we'll talk about security, which is a really brand new thing for the introduction to the industry of the world's most secure industry standard servers, and we're really proud about that. We started with our great engineering and our technologists several years ago looking at what the attack surfaces were and where we needed to go with security, and have met that demand, that need, because as we've seen now, those attacks are going up exponentially. And so we have introduced or branded the HPE Secure Compute Lifecycle that really is this holistic approach to security all the way from cradle to grave at the very inception of a product, all the way through the production, manufacturing, supply chain for the product into the customer's location, and then finally to the natural end of life of that solution. And it's based on our HPE differentiated new technology, the Silicon Root of Trust. So let me just talk about that briefly, because that is really the key of what one of the keys of what we're doing here. We're actually anchoring into the silicon, and we're in a unique position at HPE because we design, develop our own custom HPE ILO 5 silicon chip. And by doing that, we're able to open the gates, burn the gates, and embed the cryptographic algorithms that are necessary so that we can tie to that or anchor into that all the rest of our Server Essential firmware. ILO, UEFI, CPLD, IEME, and all that's tied in and has that firm foundation. So unlike our competitors that try to anchor some of the firmware, we're actually anchoring down into the silicon itself. Our competitors generally buy off-the-shelf ASICs, and so they don't have that capability. We do, and we've leveraged that, and we've come up with Silicon Root of Trust that provides this ultimate protection throughout the supply chain into the customer. And then when it's at the customer's site and it's up and operational, then we do monitoring or detection of any malware or compromised code that might be inserted at any time, because we're checking that firmware on a regular basis. And then if there's anything that's detected as an anomaly or some type of security issue, then we can actually recover. So that's a really strong story between the protection, then the detection, and this ability to recover. Those three things are unique for us that we're offering. We also are incorporating the new commercial national security algorithms, the CNSA suite, that is a set of the strongest security ciphers available in the world today. That is one of the operational modes for our Gen 10 servers. So unlike our competitors that may have 2, maybe 3 modes of operation, we actually have 4. The production mode that it ships in, and then high security mode, FIPS mode, and then finally CNSA mode at the very top, CNSA suite mode. So that's really differentiated. And then, of course, we're working and applying the NIST 853 controls to a solution set of the HPE equipment. And I think that's really important. We've seen a number of things happen here recently. Well, there was a federal executive order that came out, I think it was May 11th, required all federal agencies to apply the NIST standards or controls to the cybersecurity prevention practices, right? So here we are at HPE, just in time to delivering some of these security controls on our solution set. That shows, I think, real innovation and forward thinking on the behalf of HPE. So all this goes together to provide a really good, solid security story. It's a life cycle. It's from cradle to grave, and we have, a comprehensive DCIG, even EG or HPE look, because we've got point-next services that provides security and protection services, as well as supply chain that has anti-counterfeiting, anti-interdiction, and a bunch of things that they're doing there that are unique and differentiated. We also have, with our Aruba networking, we have Naira now that applies some machine learning inside the network, so we can proactively determine if there's any type of behavior that looks like it's a bad actor inside, and then block that user out temporarily before any damage is done. So we're using that to take security to the next level through machine learning. And of course, with our 3-part, we've got great security protection there. So we're tying all this together to a really very firm, comprehensive security approach. Yes, sir.
So where do you have your ILO chips fabbed? Because physical security during the manufacturing process is absolutely paramount to creating that root of trust, right?
You are absolutely right. In fact, I've talked to some customers that say, you know what I'd like, Bob, is I'd like a security guard to go with your solution all the way through. And that's kind of what we've done, in effect, with the Silicon Root of Trust. And we produce we have a USA-made BIOS, which I think is pretty key. And the ILO chipset itself is made in a TAA country, so we're very confident that as we put that together in a TAA-approved country, it's very secure. It's HPE silicon that has that anchor inside of it, and then from there on, it cannot be breached. And if it is breached, if it were to be breached, then we would be able to detect it. Good question. Okay, let me just finally cover, because we talked about agility, we talked about security, and economic control is the last one. Of course, we have some stuff that we're offering there, and I think some of the HPE point-next services are really great, and they help provide that same approach that you get in with public cloud, but on an on-prem environment. So we have capacity care, where HPE point-next services will sell you the amount of compute power cycles that you need, and then or scale back if you don't need that. So they'll come out, deliver that. That's a great solution for the customer, also for some of our value resellers, because they can be the ones to go out and deliver those new hardware solutions to the customer. It's great for customer retention for the resellers as well. That provides that public cloud experience of just paying for what you need without getting locked into the public cloud. Because as we all know, once you get up into some of these large, big public clouds, it's very difficult to extract yourself from there. So you can run that. We also have a partnership now with Mesosphere that provides you some of the same flexibility you would get in a public cloud, but you can do it on HPE approved hardware in your own on-prem private cloud type environment. And then I'll turn it over to Milan. This is Milan Shetty. He's our CTO for DCIG, and he might have a few things he wants to add. I'm not sure.
You covered it very well. I'm just going to help with any questions which you haven't covered between you and Brent. You guys did a good job of covering the entire announcement. So yeah, that was really well done.
So back to the Silicon Root of Trust. If I equate what I heard to what we have today in the modern PKI, where we've got private public key, certificate authorities, things like that, I'm going to work under the assumption that HPE becomes my root CA, and I've got the equivalent of a certificate baked into that ILO. When I say baked in, is that something that expires? So we have to worry about certificate replacement, the equivalent of? And if not, if there is a compromise of that chain, how do we update, replace, remediate without pulling the entire ILO chip, which is on the board?
Right. Okay, so let me take the second part, because that's really the fabulous thing that HPE is doing here. And the answer is, we're doing a secure recovery automatically. With the new ILO Advanced Premium Security Edition license that we are announcing and will be selling when with Gen 10, we actually have as part of that the secure recovery. Therefore, we're keeping a safe, authenticated, good copy at another location inside the server. It's not the A or B side to the firmware like you are typically familiar with. This is in a nondescript location where it can't be breached, and we can recover. We check that on a regular basis to make sure it's authentic and malware free, and then we recover to that. So if there is a breach that's detected, somebody gets in somehow to physical access and puts some leads down on a spy part or something and puts some compromised code in there, it will be detected because we're monitoring. We have the firmware runtime monitoring as part of the license that we're selling, the security edition. We will catch it. We'll send an audit log out. That audit log can be read by the customer just because it's a simple ILO audit log. Also can be registered as part of an ASIM tool, like if you're running ArcSight on top of that. So that can catch it as well and alert the customer to that. And then the customer has three choices. One, don't recover because I want to take that server offline and do some forensics on it, because sometimes they want to do that and see where the hacker came from. Two, recover to the last known good state, and they go over inside the server and they fetch that ILO, that entire UFI ILO firmware. Or three, they go all the way to back to the factory settings if they want to, just to be extra safe. So it happens securely and automatically. I do want to make a point about firmware upgrades, because I do get that question a lot. Because those upgrades will come from HPE, they'll be signed, authenticated, and so it'll naturally match the encryption that we've got or the algorithm that's in the. So there's no delay to or no problem with making updates to the firmware. I think that's probably important that we mention as well. And then you want to know, does it change or do you have to? It won't. So as long as you have that server, that Gen 10 server with the ILO 5 silicon chipset, it remains the same. It's embedded in and anchored to that silicon. It'll be the same for the life cycle. There's no need to replace or pull out the silicon chipset there. And I think does that answer your question?
Not exactly.
Okay.
The answer that you gave was to compromise of the ILO code itself. What I was driving more towards was the signaturing itself. So think in software terms, just traditional software running, we have the signature for the code itself. Right. But we also have the signing portion needs to be maintained. That chain of trust needs to be valid and good and trusted all the way back. We have had instances in recent memory where some of the authentic code signing from Microsoft has been stolen, duplicated, and we had what looked like good, clean code that had malware in it. Right. And therefore, that's really where I'm driving towards.
Yeah, and that's perfect, because what we do now is we have this second layer of protection, because let's say you get the signed firmware update from HPE that's validated as authentic and it's all been signed by us, but you're saying it gets interdicted or something and there's some malware put it?
Not so much that, but somehow somebody is either brute forced the key.
Their way in there to a key. Yeah, well then as we update it, it wouldn't match the silicon, the algorithm in the silicon, so it wouldn't run that bad code.
And one of the things we haven't quite publicized is that we actually do have multiple keys and multiple hashes there as well. So it is possible to have multiple different roots if the core root was compromised for some reason or for any reason. It can pick up different root. So it kind of works very similarly. Very simplistically put, it will work very similarly to like a blockchain concept, but you can have the source. You don't rely on just one root. You actually can have multiple roots, but not multiple roots at the same time. The second root is only activated if the first root is definitely compromised or the hash has been figured out somehow. So you can go to and the firmware has the mechanism to figure out, and that's what Bob mentioned about the detect, protect, and recover. That's part of that stage. Is you can actually do have if the hash is compromised to get to a different hash.
So there's going to be some sort of online repository that.
That's right, and we know what the hashes are, and we know what the roots are, and everything. But that is I would call the nuclear option. right? Because most likely what's going to happen is that the customers would, our belief is, and again, this is new, the entire industry will have to adopt it and everything, or the customer base has to adopt it, right? Is the three scenarios Bob mentioned, right? Go back to the factory setting, or go back to the last known good state, or just pull the drive. Our belief is, and again, the serviceability and the use, how people use it is going to be very interesting here, is that our belief is that when something that dramatic happened from a nuclear standpoint, customers would probably want to go the forensic first before they will take an option of going to the second route. Because with virtualizations and stuff, you can move the workload and try to figure out what happened so it doesn't happen again. And so going to the alternate route of chain is probably going to be, we believe in a life cycle of a product, we may have to activate it like 1 or 2 or 0 times. But that capability does exist.
Is there going to be the need in the algorithm as you guys perceive it for online revocation lists that the ILO is going to have to reach out and update itself, just not from a firmware standpoint, but to get?
Yeah, so the revocation, so the base certificate is probably not going to be revoked unless the nuclear option has to be triggered. But the chains, we do anticipate revocation is going to be as a possibility, and that is already baked in. But the root is not going to be revoked without that nuclear option. But in any scenario, you don't have to take the ILO out or the motherboard out to go through the entire life cycle of all the different incidents which could happen.
So when we think of the chain, are the individual fabs going to end up being intermediate issuers essentially?
That's right. And that's how we would know, right? Because there are lots of parts and lots of options which will come in, right? NVMe drive, as was discussed earlier, or flash and everything. Where we want to take this ability is that today it's only on the server and what is attached on the motherboard and the firmware attached to the motherboard. But you also want to take it to the option side of things which are plugged in. And that's kind of the security roadmap. But it could be a NIC driver or NIC card which is getting plugged in, because that could be in surface area down the line, right? So those things we're also going to take a look at. Not only that, where we want to take this is then also go ahead and everything which is connected to the server. There could be the external storage, external switches, external. So we extend that chain not only to what's on the board and the firmware on the board, but also the options on the server, and also externally attached components through either fiber channel switches or Ethernet switches. So that's our goal, and that's how you just start reducing the attack surface, and that's the plan.
So when you talk about how it's going to be able to analyze behaviors and watch for suspect behavior and flag it and let you do some number of choices, is that something that's going to be tied to firmware rev, or is there going to be more dynamic updating so that you can quickly get new behaviors released based on zero-day exploits that are discovered, et cetera?
Yeah. So now we're talking a little bit of the future. So some of this is not definite in the roadmaps. I'll give you the theory of operation on how we are thinking about this. So we believe the way this is going to do there is going to be some machine learning which will go in ILO at some point. Because ILO's got the CPU complex and also the memory complex on ILO is sufficient enough to do some rudimentary machine learning to detect some of the outliers and the stuff which is happening. So that is something which we are thinking through on how to implement that. And much like the antivirus and the antivirus description files get updated periodically, we do believe when we get more components attached to this secure root of trust, we will have ability to just change the definition files on a periodic basis. So very analogous to the antivirus industry on your PCs. But that is something which we have a lot of work to do to get that.
It's pretty obvious where the question came from, right?
Yeah, absolutely. But it's going to mirror. I think the use case is going to mirror very much like the definition files and everything to update only the pieces without having to update the entire firmware. There is another dimension to it which we are thinking through is the online upgrade pieces. Because you don't want to take your server down to do any of these upgrades and everything. So that's another dimension from a resiliency standpoint, which we are thinking through from a roadmap standpoint, how to introduce it very safely and very securely.
I'm curious from the economic control perspective. Just trying to get an idea. I know there's probably a wide variety of options, but if I'm seeking to shift some of my computing from existing fixed, capex to more of an opex model, how should I be thinking about that from a budget perspective? Am I kind of thinking about this as perhaps a 3 to 5 year lifespan of that pricing up cycle, or is this going to be available on a month-to-month basis, yearly basis? Kind of, can you shape out a little bit of the flexibility that's available from that OpEx perspective?
Yeah, I think we've run a couple of models, and in fact, if you go out to booth 401, they actually have a little alert monitor that shows you when you need to add additional capacity and what that savings is like. I think a lot of it depends on if the capex is important to you or opex. Certainly, some firms are more sensitive one way or prefer to go one way or the other. But we have created some models and run some models that show what the ROI is, and of course, there are some break-even points depending on how long a period of time you're looking at.
I think the flex capacity model, I think from a use case standpoint, because we have such a very large install base from small and medium businesses to large enterprises, the infrastructure, both on the flex capacity on the compute side as well as on the storage side, the flex capacity itself is flexible. In that when customer sees the experience, they can plan for it on a monthly basis, quarterly basis, or yearly basis. The granularity is on the monthly basis and the monthly invoicing model from the least granular and from the maximum granular it can be an yearly basis. Very few people I think would take the option of a 3 or a 5 year, because folks who are generally shifting from a capex to an opex model are thinking generally from a customer use case standpoint for a sub 3 year kind of model, because that's because if it's a 3 year model, then it's kind of like capex anyways.
Right, but just considering, say, purchasing a core on a month-to-month, quarter-to-quarter, year-to-year basis versus purchasing the equivalent of computing on a permanent basis, is there kind of an idea of how much that would cost in comparison? Do you have kind of benchmarks, kind of rule of thumbs in place?
Yeah, so to Bob's point, I think there are a bunch of modelings which are there in the booth, because it all depends on the configurations too, right? It's the and that when the ROI and when the tip over happens between one model to the other model is definitely something which has been and there's a lot of work which the team has done around modeling that.
Yeah, in fact, do they let you guys out here? Can you get out to the floor sometime? It'd be good to come by, because we do have a couple of scenarios model, and they show you what the different break-even points are. Okay, we appreciate your time. Is that?
Thanks, guys. That's been really useful, and that brings our next gen compute. We do have about another 25 minutes before the final session of today, which is the HPE vision for the data center. So we'll catch you live in about 25 minutes. Thank you.
Thank you.
All right, everybody, we're back for the final coffee talk today, and almost the final for the conference. We just have one tomorrow morning, so 2 tomorrow morning now. Excellent, 2 events tomorrow morning. Here we go. I'm being informed as I stand here, or sit here. So our final presentation today, I'll hand straight across to you, Mark.
Great. Hi, everybody. Can you hear me okay? Yeah? So my name is Mark Linish, for those of you who don't know me, and I work for Mark Potter in the CTO office and labs. And my job is fundamentally strategy, working across the different organizations, and primarily on what we call Horizon 2 and Horizon 3. Think about the first 18 months, really Horizon 1, where we're actively, kind of enhancing our roadmaps and these kinds of things. Horizon 2 being kind of beyond the 18 months into 36 months, where we're doing advanced development, proof of concepts, incubations into different things. And then Horizon 3, which is more of your, kind of research-oriented stuff. And so I get the fun job of working with just some incredible researchers and engineers on the future, quite frankly. And, I think as you come to a show like this, you see some of the results of some of those talented engineers, some of those talented product marketing people who are, out there trying to, make headway in terms of our next generation compute and storage and networking, Gen 10, some of the security environments and those kinds of things. The 3 key vectors that we're kind of working on right now, number 1, of course, would be hybrid IT and continuing to kind of enhance the overall efforts there. Number 2 is, of course, the work in the intelligent edge, and we're working some advanced development areas there. And then 3 is really memory-driven computing and the analytics, machine learning, artificial intelligence, algorithms and frameworks that really are starting to get turbocharged by these kinds of systems. And so, I'm excited to be here. I'm excited to dialogue with you guys. Let's make it really informal. It's the end of the day, and I'm standing between you and a beer. So, let's kind of open it up and see what kind of questions you have about either where Hewlett-Packard Enterprise is going, what some of our technology strategies are for the future, or whatever you're interested in.
I have a question regarding Gen 10. So I was checking the website, and there's a new microserver available with the Gen 10 generation, but it's not as secure as the bigger option that we have, all the ProLiant servers. So, I'm assuming this server is intended to the branch offices and probably home users, but is HPE trying to get into every house as possible, or the microserver is intended for something else?
My understanding is, and I'm not an expert on the microserver, but my understanding that it is for a small business, right? And that it's really designed as a service experience for a small business. So integrated gateway, integrated internet capabilities and the like. And probably the reason why it doesn't have the Gen 10 security is probably a cost point issue having to do with ILO silicon. If you remember from the discussions you've had on Gen 10, right, the secret sauce in the security and being able to create that root of trust, if you will, is being able to fingerprint the firmware with the ILO silicon throughout the supply chain, the bring up and the lifecycle management. And so my assumption would be that that microserver does not have an ILO chip in it, and so it probably doesn't have the new security features that the rest of the Gen 10 platforms have.
But that's going to change how the future of the data center is going to show? Are we going to be using, instead of one unit servers, to start using microservers and just stack them, everyone in the data center, in the future of the data center?
But that's not where the microserver is targeted at. The microserver doesn't go in a data center. It goes in a cupboard at a small business or a branch office.
That's true, but if you think on the future of the data center, we are thinking about segregation. And if you can say the future of the data center is not having 1 or 2 unit servers, it will be having small servers with the same capabilities, but very segregated by every customer.
Well, I think there's lots of different ways to skin that cat, right? In a large data center and in an enterprise, you might want to skin that cat with multi-tenancy or other types of composability types of functions, synergies and those types of things. But I think you're right. The microservice is really targeted at a very small business who has absolutely no IT whatsoever, and is really designed to be managed and operated in a very simple and easy way, right? Now, I was out on the show floor, and one of our partners out there called Mindbox is doing some pretty interesting things. They're basically taking those microservices or microservers, and they're creating a peer-to-peer storage area network like a Dropbox with security supplied by blockchain so that they can create a secure peer-to-peer network of devices that can share their storage resources. So for instance, they can use it as a small business could use it as a Dropbox backup and recovery capability, and you're sharding across sort of multiple peers, and so you've got a lot of resiliency here. But the really interesting piece about the business model is that if you have excess storage capacity, you can provide it to somebody else and sell them that excess storage capacity through Bitcoin. So these microservers today are targeted directly to small business, but these peer-to-peer networks and some of these other kinds of capabilities are very interesting. I don't disagree with you that there's lots of different ways to think about kind of those servers, but that microserver that we're talking about definitely is not designed for data center environments. Okay?
Yeah, the data center version of that vision of scaling out lots of little servers is Moonshot. And that's one enclosure with enterprise class features, but lots and lots of little modular servers inside it.
Other questions or thoughts? Yeah, yes, sir.
I'm curious about HPE's data center strategy in terms of data center switching and networking, and how that might tie into the whole composability initiative and also initiatives like NewStack.
Yeah, I think the data center strategy that we've had in the past has been a little bit reset, right, with the spin out of the HCA stuff from China and the Flex Fabric stuff. And so, really we're continuing to sell the Flex Fabric line as a traditional switching capability, right? But a lot of the focus today is really on our partnership with Arista and software-defined networking, and looking at then how do we tie that software-defined networking closer into some of our, OneView and composability kinds of features. And I think that there's other opportunities on the horizon. I think, did you guys take a look at the new Aruba switch, for instance, the core switch? That came out of some of the work that we've done in open operating systems, right? And that's an entire software-defined platform, open APIs, REST-based APIs. You can use tools like Chef or Puppet to do configuration management and the like. And so we really have a lot of different technologies. We've got traditional Flex Fabric capabilities for some of our enterprise customers who want that. We've got these new, kind of Linux-based open operating systems like what we just announced with the Aruba core switches. And then we've got this deepening partnership with Arista for software-defined networking. And I think what you'll see moving forward is, that partnership started out as primarily a go-to-market partnership, but there are really good technology opportunities for us to better integrate the Arista capabilities into some of our composability strategies, some of our provisioning strategies moving forward.
Could you just provide a little bit more context on the nature of the relationship with Arista?
In what way? I mean, by what do you mean by the nature?
So when you say go to market, does that mean if you're talking to a client and they happen to need they're looking at Leaf Spine, you say, oh, well, we have a partnership with Arista, and here's how we can do some things together, or what is this?
Yeah, absolutely. I think part of what we're asking our partners in our direct sales force to do is to kind of qualify a customer as to, are they a customer that wants open networking? Are they a customer that wants software-defined networking? Are they a customer that wants traditional networking? If they're a customer that wants software-defined networking, then we're going to steer them to the Arista partnership, and we're going to kind of work jointly with Arista to kind of land that customer and to make sure that those networking products and capabilities are working well with those in those environments. And these types of partnerships, quite frankly, are things that we do pretty well. We do a pretty good job of working with companies like an Arista, like a Mesosphere, like a Docker, and doing both joint engineering, joint R&D, joint innovation, but also joint go-to-market. Okay. Other questions? I know this is a tired crowd, right? I can already see that. Yes, sir, Mr.
A little bit closer in on networking, silicon photonics. Well, photonics in general. You guys have the X1 VCSEL-based technology today. Some farther future silicon photonics. We heard earlier today that I think the hyperconverged chassis are plumbed for fiber, although they're not using it yet. Can you give us some idea of? It seems like one of the early technologies that'll be commercialized from the machine. When will we see fiber more widely deployed in mainstream servers, hyperconverged?
Well, that's the current $1 million question within Hewlett Packard Enterprise, and the discussions we're having with our different product divisions. I think that X1 chip and some of the capabilities there, we need to commercialize not only that chip, but the kind of switching technology associated with that. And so, as you said, Synergy is plumb for photonics, and we're in the process of the way that this works between kind of our advanced development and labs area and the product divisions is the product divisions go through a very kind of structured way to introduce a new product, and it's build a concept, then do a marketing requirements document that makes sure that you've got the right features that meet and fit the customer requirements, and then do what's called a plan of record, which is the actual funding of that product and into a new product integration cycle, right? So where we are with our business units today around photonics is we're looking at these different concepts, and so we're in that first phase, if you will, of concept development. So I'm thinking probably sometime in 18 or early 19 will be the sweet spot for our first introduction of some of those photonic capabilities. And it may be that we'll actually do photonics earlier than that using kind of industry standard parts, and then follow that up with an X1 more organically developed capability from Hewlett Packard Enterprise. So we're still in that process of kind of working through those concepts and looking at the different alternatives. Okay.
So where do you see the intelligent edge picking up over the next few years? I mean, we've seen a little bit of the IoT and the edgeline servers being deployed out. What sort of direction do you see that? Is it more density of computed edge, or just there's going to be more things out at the edge with compute in them?
Really, all of the above. I've been really pleasantly surprised at, quite frankly, the amount of business, the amount of engagements that we're seeing across our mobile edge, wide area network edge, and industrial edge. We have today, we just completed a proof of concept and are now signing a fairly significant agreement with a major industrial company automating 400 of their factories around the world with edgeline gateways and and devices. And so I think what you're going to see is more and more computational power at the edge for a particular class of use cases. So if you think about separating use cases, there's use cases that you need to ingest and aggregate a lot of data, and it's so much data that you don't want to send it back to the cloud. So you want to analyze it at the edge, and not only analyze at the edge, but potentially it may be a real-time response. And we see that a lot in process industries, right? Where what you'd like to be able to do is do some type of capture of anomalies or different parameters that are out of whack, be able to do that analytics very, very quickly, and then respond back to the process pretty quickly. Other applications, like smart city applications, where you're connecting, let's say for smart trash removal or smart lighting or those kinds of things, or using low power connectivity, low RAN and things like this, and they don't have a very large data rate, so it's going to be thing to aggregation to the cloud type of a thing. So we really have to kind of separate the applications that require computation at the edge from the applications that maybe don't require computation at the edge. But applications like harsh environments and industrial applications, oil rigs, these types of things are definitely part of that. And I'd say something else about that, which is that what we're going to be seeing here in the next few years is we're going to be seeing a real dance between the edge and the core. Okay, now think about the core is where you, let's say, train a next generation machine learning model using, a whole bunch of clusters and a whole bunch of data. You're going to want to then containerize that model and push it down to the edge. When it's down at the edge, if it's a real-time response type of an application or a big data application at the edge, then you're going to want to do your inference at the edge. And increasingly, we're going to have it be more machine-like because you're going to want to put that entire model into persistent memory so that you can get the response times that you're looking for. And you may even have acceleration at the edge through a GPU or an FPGA. So we're looking at these next generation edge environments, and we're saying, really, the sky's the limit to the extent that we can build a variety of different either gateway or computational devices that will fit a lot of these different use cases. And then the other part of that is being able to do the data and model management between the edge and the core, right? And so as you execute a model at the edge, you find out that the model needs some additional training, then you retrain at the core, push the model back to the edge, and keep on going.
Yeah, so you're doing sort of anomaly detection around your model at the edge. As a result of anomalies, you'd have to develop a new model and then distribute that back.
Correct. And one of the things that's on the show floor that you guys ought to take a look at is something we call distance deep learning, and a protocol that we use to collect those anomalies and then send those to the core for retraining. And that's an innovation that right now is in a POC status in our advanced development, and that hopefully will find its way into a productization cycle over the next 12 to 18 months.
Yep. So I've been hearing talking about compute power, photonics, workload, storage, but I haven't heard anyone talking about energy efficiency. For the future of the data center, it's important to have a storage, but I feel that the conversation has to be driven about energy efficiency and how we are going to be powering all these powerful machines that we are going to be having in the future. What do you think about it?
Oh, it's a great question. In fact, one of the key drivers to our machine research and to next generation memory-driven computing is the fact that we cannot sustain the energy as these data centers around the world, as the cloud and as IoT continues to mature and become more pervasive. And so part of what we're doing with photonics and part of what we're doing with persistent memory is very, very focused on energy savings. And let me give you some examples. Today, what happens is you're shuttling data back and forth between the hot and the safe, right? And going from the disk drive to the SSD to the memory, working on the problem, and then spinning it back out for checkpointing and things like this. With and DRAM is a continual refresh, and so you're not only shuttling data back and forth, which is very energy intensive, but DRAM, you're always refreshing that DRAM, and that's energy intensive. With persistent memory, things like 3D XPoint, the memory version, Memristor, and other devices that are coming down the line, there is no refresh cycle, okay? There is no power that needs to be applied to a Memristor, with data. It's a persistent type of a thing. So you're saving lots of power because of the no refresh, and you're saving lots of power because you're holding the data set in memory and you're not going back to disk or to SSDs and shuttling data back and forth. That's on the persistent memory side, and that's a big deal. Number two way to save memory is that copper is hot, light's not. So as the world moves toward more and more photonics, we'll get a big energy savings with regard to shuttling data between the nodes and across the data center. The third aspect is that when you hold a model into memory, one of the things that you can do is instead of recomputing the model, you can just change the pointers to a lookup table and get the difference, right? And so we've proven out with the machine that in a Monte Carlo simulation, by rethinking the algorithms and instead of recomputing the random walk in a Monte Carlo situation to get higher and higher accuracies for derivative pricing, that we can just change the pointers in memory, do a lookup table, and save enormous amounts of recompute energy for these big data and simulation kinds of applications. So you're going to see huge huge energy benefits as the world moves toward persistence, photonics, and these new types of in-memory types of applications. Sir.
Hybrid cloud has been a clear part of a HPE message for the last couple of years. I'm wondering why only now we're learning about an orchestration tool that can really enable that in terms of new stack, and why that wasn't part of a strategy from day one.
That's an interesting one. I guess my perception is that HP has been a pioneer in thinking about hybrid cloud and thinking about the fact that one size doesn't fit all, that quite frankly that you're going to have some of your IT services in a public, some in a private, and what you're really looking for is an ability to manage all of those IT services from a cost, from a business control, from a security, from an operational perspective. And the reason I think that you're seeing new stack now is because our customers are starting to become very familiar with the notion of hybrid and are now starting to say, I need these types of tools as I move into my more focused hybrid strategies. To date, we talked a lot about hybrid, but I didn't see too many customers actually executing a hybrid in a pervasive way. So I think that the timing actually is pretty good for NewStack in terms of enabling our customers on their unique hybrid journey. I will tell you also that the evolution of the industry's thinking on hybrid has come a long way. We used to define hybrid as, well, we can burst into a public cloud, right? And then it was like, well, we can get visibility across a couple of different clouds. And now we're saying, well, look, you can stand it up in Google and Amazon and Azure, okay? And we can connect all three of those IT service delivery capabilities with your existing data center capabilities and bring that all together into a unified dashboard for control, for operations and the like. And it's somewhat unique. I don't know that there's another tool out there that is as aggressive in kind of thinking about this as NewStack is. And we've gotten great customer feedback and interest on that. Now, it's still early days, but we've gotten feedback that this is a capability that our advanced customers who are on that hybrid IT journey are really looking for, and they haven't found necessarily the right tools. And so we're fairly hopeful that this is going to be an important addition to our hybrid cloud strategy. But time will tell. Okay?
So I got to say, I've had customers, I have a specific customer in New Zealand, and maybe you should be testing this in New Zealand 5 years ago, but 5 years ago a customer said, what I really want is a console for my business units where they can choose where they want to deploy their application, and that there's some governance around. They have to declare what kinds of data they're holding, and that will allow me to constrain them about where they can deploy this. And this is exactly the sort of things that I understand as NewStack. Customers in New Zealand a specific customer asked me for this 5 years ago.
That's a great comment. I mean, I think the other thing about NewStack is that it's infrastructure as a service really targeted your operations folks, right? For the most part, they sort of, kind of said, okay, well, look, IT, I want you to, sort of give me IT services faster. And the operation guy said, well, look, I'll give you VM vending, or I'll give you, kind of minimal cloud kinds of things. But your point is very well taken, is NewStack is really designed for three personas. It's designed for the line of business persona who cares about business controls and who cares about, being able to stand up separate workspaces for different things. It's designed for the DevOps community to bring their tools in and to kind of quickly build their pipelines and these types of things. And then it's designed for the operations people. And so I think we've learned a lot about how to make this stuff practical, make it real world, and make it valuable for people. And that's what we're doing to kind of envision things like NewStack.
So I think we've mostly been talking about things that are in the horizon 2 that are going to come out in the next 2 years kind of phase. What are the exciting things a little further out on the horizon? What kind of things are you still trying to form into a real idea that are still a little further out?
Well, that's a great question. I think that further out are cognitive computing chips that can better meet the engagement with the analog world. We have a couple of long-range government contracts that allow us to do fundamental research on how to use resistive technologies, memristor technology, to do analog to digital accelerations that are fairly significant. The whole area of deep learning is exploding right now, but there's still a lot of work to do around kind of making deep learning something that is accessible to your average enterprise and that they can kind of bring into focus. One of the things you saw in the labs area or you might have seen in the labs area, is our deep learning cookbook, which basically looks and says, okay, well, for this use case, let's say real-time video analytics, right, which a lot of our customers are interested in, then you should use this deep learning framework and then this configuration of Apollo systems to train it on and this stuff to inference it on. So I think that both some of these cognitive computing accelerators, some of the deep learning capabilities that we're doing, some of the work that we're doing long-term on exascale computing, where the governments around the world are saying, what's next in terms of being able to get to petabyte scale and these types of things, is work that combines our high-performance computing with our machine research and says, well, how do we stand up a petabyte and just thousands and thousands and thousands of cores, and how do we operate that at scale? And so there's lots of those types of things. You've seen out in the show floor us doing some incubation work on blockchain, right? Now, the work that we're doing with blockchain today is primarily in the financial industry. We did a session earlier today with one of the customers in your favorite place of Australia, Commonwealth Bank of Australia, and we're incubating a proof of concept with those guys on blockchain. But blockchain can be used for a number of different use cases, including a lot of use cases in the IoT space. And so that'll be one of the things over the horizon as IoT starts to mature a little bit that you're going to see a lot of interest in, is a machine-to-machine blockchain capability so that you can transact value. So those are some of the things on top of my mind anyway.
Cool.
So, Mark, when you think about where things are going and some of the changes, several of the things that you articulated take a pretty demonstrable shift away from the classic HPE kind of creed and history and focus, right? It's moving away from infrastructure, it's moving away from that core hardware piece and moving more toward applications and software, right? Especially as you start talking about machine learning, you start talking about cognitive, you start talking about deep learning. How exactly is that going to happen within HPE? And as part of that, that's a totally different customer than HPE is typically engaging with. So how are those two things going to resolve each other as we go through time here? Because it's great to talk about it, but my concern would be, how are you going to be able to execute on that on both fronts?
I have concerns about execution every day, so it's not a new subject for me, but I would disagree a little bit. I think that HP has more software developers than we do hardware developers, but let's take the area of machine learning and deep learning, okay? We have an approach to that I'll kind of lay out for you, and it's really, kind of 5 things, right? We do fundamental research on, kind of deep learning, machine learning kinds of algorithms, and we do a lot of research on algorithms, quite frankly, and so this is an area where our labs people have historically added value and the like. We do fundamental work around VLSI, quite frankly. We are doing the chips for photonics. We're doing the chips for next generation ILO. Okay, we're doing the chips for network acceleration and these kinds of things. And this is a core capability that most people don't even know exists within Hewlett-Packard Enterprise.
So let me clarify then. When you talk about machine learning and cognitive and deep learning, are you talking about specifically that as a wrapper to infrastructure, or are you talking about it in the broader sense of, I have business applications that are trying to engage in deep learning and machine learning aspects?
Yeah, so our model...
Those are different.
I understand. Our model is we're going to enable deep learning, machine learning for our customers through point next services, discovery services, road mapping services, through injecting deep learning into our own management and automation capabilities. An example of that is Niera for the ClearPass policy and behavioral analytics piece. We're going to be creating partnerships with the deep learning frameworks, and we recently announced a partnership with NVIDIA around their complete frameworks and capabilities. And we're going to be building optimized platforms and accelerators for deep learning and machine learning applications, and we've announced some work that we're doing with the Apollo platforms in that particular area. So optimized platforms, deep ecosystem partnerships with the frameworks that are out there, both the open source frameworks and the vendor specific frameworks, injecting this machine and deep learning technology into our software defined infrastructure management automation capabilities, and then helping our customers through Point Next and through our SI partnerships to actually build out use cases and those types of things. We're probably not going to do a whole lot of application development and those kinds of things, but we're going to enable these deep learning use cases and applications through our services arms and through our partnerships with SIs. That work? Yep.
A little more pedestrian question. When you hear it, you'll understand why I phrased it that way. In the past 18 months, we've seen the cost of flash drop, and we've seen the densities go up. Of course, magnetic media is nowhere near as quickly growing. We still have 6, 8, 10 terabyte drives on the 3.5-inch form factor. HP has got to have their thumb on the pulse of where the fabs are, when we're going to theoretically hit that inflection point, or better stated, intersection, where spinning disk has the same cost density that flash has, and we're in forecasting that for strategic purposes. What's next? We already have seen things from HP like a 16 terabyte, 2.5-inch form factor SSD, which we'll never see that level of density from spinning disk. There's just, I think it's physically, literally physically impossible for that density for mag media. What are the thoughts for the data center side when we're really are discarding spinning disk and we're not dealing with the space, the heat, the energy, and it's all solid state?
I'm not close enough to give you a real practical, definitive answer on that, and let me tell you why. I predicted that mainframes were going to die about 7 years ago, and they're still around, right? So I'm not one of these people that calls the death of magnetic and spinning media. I think it's going to be very useful for cold storage for quite a few years. But would I be betting on the growth of magnetic and spinning media? I would not. If you think about where we are today with SSDs, and then you project that they're going to get faster and more denser, and they're going to get into multi-packaging, and they can stack them and all that kind of wonderful stuff, I think we're going to continue to see all flash all the time. And then just around the corner from all flash all the time, and we're already seeing that with our 3PAR and Nimble teams, we're going to see memory-driven, what they call storage class memory, which is near the speed of DRAM, okay, and you can do load store operations. And when that goes persistent, when 3D XPoint enters the picture in the second half of 18 or whenever they deliver that, when Micron delivers their capabilities, when Samsung delivers their capabilities, when Memristor enters the picture, then we're going to start to see a new tiering happen. We're going to start to see very fast, high bandwidth memory attached to an SoC, but then we're going to see this, abundance of storage class memory that we can do load store operations with, and then we're going to see another tier of very fast SSDs, and magnetic media is going to continue to dwindle in terms of its place in the hierarchy, right? And that's because of its energy, that's because of its reliability, and as you say, it's going to become increasingly because of its price performance. I just can't give you a date. Now, some of our storage guys could probably give you a more precise date, given the fact that they follow it in a weekly, monthly time frame. So, but that's the best I can do.
Well, I think we're drying up on questions for you, and everybody's feeling very fatigued and brain full and somewhat woolly.
Yeah, I believe that. Yeah. Well, I just want to thank you guys for hanging in there and for your interest and your questions, and particularly for your feedback. I think one of the things that's so important for us is that you guys continue to challenge us and continue to provide feedback in what we're doing right, what we're doing wrong, what you don't understand, what you disagree with, right? Now, all your disagreements, send them to Chris, okay? All your praise, I'll be happy to take that. But thank you so much for all your time and your efforts, okay?
Thanks, Mark, and we'll be back on air 9 o'clock tomorrow morning, and we'll catch you all then.
It's Miller time.
No, he was on stage earlier.
Oh, yes. That's it.